Hello. How are you doing? Welcome to the stream. I'm Martin Shkreli. Hopefully my stream doesn't crash. We crashed yesterday. Sorry about that. What's up? What's up? What's up? Okay, what's going on in markets? We had a strong day for quantum yesterday. Now we're selling off a little bit. Although the PQC, like shitco quantums, like Lays and BTQ, were kind of dropping yesterday, so it wasn't totally strong. It was just really D-Wave. Nvidia's at 195. Wow, way to go. You got to think Nvidia's getting close to a top here. I mean, it's hard to tell, but we don't know when the SLS data is coming, so it's very hard for me to short it because I just can't determine, when we expect that data to arrive. We've been waiting years for it. The company keeps sort of pushing it off.
Top news.
Sorry about that. I'm not tempted to short Nvidia. No, Nvidia is a great company. There's no reason to short it. Yeah, Galt is a piece of shit. Exactly. Most companies, 97% of companies don't go up in the long run. A lot of people don't know that. People think that stocks go up over the long run. Yeah, maybe the S&P, which is the best stocks, not your little shit co. That's not going up. Sorry. Sorry. Uh what's your favorite stock? Yeah, I'm short that. Yeah, what else do you like? Oh yeah, I'm short that too. Fuck out of here. You want me to buy applesauce company? Get the fuck out of here. That's what TCI guy thinks as well. Children's Investment Fund. Look at Buffett. He's only traded a few percent. Now, if you're a specialist in certain sectors, I think you can do okay. But again, a lot of these management teams just suck. So You have to have an active hand in the company. And having an active hand in the company is a pain in the ass. Trust me. You got to tell these guys what to do. Their strategic mistakes. Fucking annoying. See if I could short some more D-Wave. Man, I hate D-Wave. Yeah, all the quantum stocks are shorts. Probably short Oklo and Joby. I'm short a little Joby. I have never shorted Oklo yet. I've never traded Altimmune in my life. Good villain. Sorry. I don't know why Spruce dropped, but doesn't bother me. Yeah, I'm basically bet big on shorting Quantum, so we'll see how that goes. It's been a rough year of being beaten up. I'm very lucky because I've gotten 5 or 6 different biotech home runs that have made it a lot easier for me to withstand this, punishment. Just pure fucking masochism. But the key is that when Quantum does go down, it'll keep dropping. I did a funny little graph I want to show you guys. On my other computers, I have to recreate it. But basically, a lot of people say that you can't make more than 100% shorting. Right? I will show you that that's wrong. I hear this all the time. Oh, Martin, the most I can make shorting is 99% if the company goes bankrupt. Wrong. Wrong. No, I have the right size position for S Spruce. I have my position size, and I'm not going to change it. Unless the price deviates materially. It hasn't really changed that much. All right. So let's take a stock like, yeah, exactly. Tim CISO knows the trick. Let's take a stock like D-Wave, say it's 35.50. And let's say every 50 cents it goes down. Let's sort of like to see how this works. Obviously can't go negative. Okay, and let's say you're short $100,000 worth. That means you're short 2,000 shares. Almost 3,000 shares, okay? And when it goes to 38, what's your profit? Well, you made 50 cents, right? And 50 cents a share times the 2,800 shares you had is $1,400, right? Okay, great. But now you have fewer shares. Why? Well, because your position has dropped. If you kept those shares, you would have $98,592 in the position. So your position goes down. So you have to increase the position by 40 shares so that you can maintain the $100,000 position. And as you do this, you can see that the profit rises quite a lot, and you make about 4x Yeah, it's just holding the size, same position size throughout the decline of the company. So you can actually see that most of the value comes at the bottom. And so it almost doesn't, like, this top part doesn't matter. Like, you really get the meaty returns down here. So anyway, that's one way to look at it. There's other ways to look at it, but okay, D, thanks for your insights. You know biotech better than me. I please teach me your ways. Yeah, there's a lot of ways to look at it, but that's just one way that might be interesting. Yeah, I saw Intilia. Yeah, I like Japanese stocks. Are you adding to your risk? I don't know. Depends on how you look at it. Nvidia's quarter ends tomorrow? Or in 2 days, 3 days? End of October? Weird. I don't have anything to add on prediction markets. Sorry, Singh. Thank you, though. Thanks for your interest. I talk about what I want to talk about when I want to talk about it. Okay? Beyond Meat, that short's over, man. Man, the insider selling at Nvidia is atrocious. It's just nonstop insider selling. Yeah. Nobody has answers on quantum, so non-answer is fine. Type shit. I do have reservations about Unicure. I wouldn't be long it up here. I think it's done great. Take the win and move on. You don't have to be greedy. Stop being greedy. Oh, I'm trying to play my DMX Spark, but it's not working. Oh well. You guys will have to live with. I don't know why I can't just have a nice fucking stream. It's so brutal. I pressed the button.
This is a certified hood classic.
I probably can't find the file. Maybe moved it or something. Trump talking with Quantum? What do you mean by that? What do you mean by that? You making things up? Oh, I don't own any Antilia anymore. Melancholy. But you know. Thanks for asking. Yeah, just look at the company filings, Jazzy. I'm not trading Antilia at all. I haven't even looked at it in years. Once a stock loses me money, I kind of move on pretty quickly. All of the quantum stocks are garbage. Yeah, we bought Cure as soon as the data came out. You missed it. We made a lot of money on Cure, but now I don't need to trade it anymore. We doubled our money. There's huge amounts of reservations that plenty of people have if you just talk to Wall Street. They didn't do a controlled trial was the first one. Cannot be years away? What does that mean? It's impossible for it to be years away? I like Abivax. I don't really know Nectar. Yeah, I focus my career on biopharmaceuticals. I'm sometimes known as the pharma bro. So yeah, that has been my expertise, pharmaceutical stocks. So no, I don't look at airline stocks or food and beverage stocks or things like that because it's sort of not my. I'm not the bro. I'm not the food bro. I will look at other sectors here and there, but D-Wave isn't food and beverage. That's QUBT. Oh, okay. Can I explain how halted works on New York Stock Exchange NASDAQ? I think you're trying to ask me if I can explain how stocks get halted and that mechanism. Can I do that? Yes. Will I do that? No. I love being a father. It's cool. When you are shorting a stock, what's your plan to timing the market? I think you're asking, what's my plan to time the market? And English is your second language. I don't have a plan to time the market. Nobody can really time the market. So I just focus on what I know, which is whether the company is valuable or not. Yeah, some of your guys' questions you can ask ChatGPT. It's a nice new program. It's very good. I have to say it is a quite good program. Google is also available. I'm out of Cure. I've been out of Cure. My positions are just short quantum. That's all my positions. All in, short quantum. If quantum goes up, my butthole hurts. Okay? Understand? That's all you need to know. What do you do when you feel angry? Well,
Top news alert, Amazon to cut about 14,000 corporate jobs and AI pushed.
Let the hate out. Hate. If you have anger control problems, I don't know, just try to avoid it, I guess. I'm a fan of Israel. America's greatest ally. Reading Rainbow. No, I don't think it would be dead by the time Quantum goes down. A little sooner than that. Don't worry about that. Skrelly got that covered. Because what I'm about to do next is diabolical. No, I don't like Madmani. I don't even know how to say his name. Mamdani. The Wu-Tang album was not good, no. I know a lot about it. Mamdani is pro-capitalism? Aw, sweet. That's good. Yeah, sorry, Warren Buffett. You spelled Warren Buffett's name wrong, so you're done. Don't do that. Don't do that. Mm-mm. No, market's not rational. That's even better. That's even better. That's what we pray for. I used to pray for times like this, so I could trade like that. You know, some of you guys want instant gratification. You need to calm your ass down. I try not to watch it too much, Bug. Bon Jovi. Well, how would that work? ASTS is the future? Future of what? I'm not sure it helps that much, Gordian. It might give you some insight. Like I've been doing it with Python here and there, but it all depends. I think anything that helps you get your head around the trial, you know, your job's to predict the trial outcome. So, you know, you want to get your head around it the best you can. I think that's kind of, you know, whatever helps you do that, including programming, anything really. All right, let me look at like trailing 12 months cash flow for NVIDIA. So we're getting a little expensive here. For a while, NVIDIA, you could kind of make the argument that it wasn't bad. But now we're starting to get a little pricey. 60 times earnings. And we might be peak cycle. Godot Terminal is like this new thing I stumbled upon. It's kind of like Bloomberg, but like affordable. And it's got a lot of stuff that Wall Street guys use, but like it's not available to like the average public. So it's pretty sweet. Yeah, I'm just checking it out. Make sure you sign up for Godot. Yeah, there's a lot of features. Like the main concept for most of the Like, I guess if you look across like what the big four have, I think it's probably easier to define that. So the big four are Bloomberg, S&P Global, FactSet, and Workspace. So maybe I should make it like a thing like this. Bloomberg, S&P, or well, I guess I'll call it Capital IQ, Workspace, and FactSet. Those are kind of the four major terminals. I guess I could put Godel here. So let's see. And I'll put TradingView here for comparison, just so you... I'll say Workspace is okay. But let's sort of start here. So community is important because if you have a community of professionals, that's good. If you're on some, you can go to a stock Discord or Wall Street Bets, but that's not good. So you want a community of professionals. So in this case, Bloomberg has one, but the other guys actually don't, which is a little bizarre. Godel has one, and I would say TradingView does not have one. A directory of Wall Street experts. Again, Bloomberg has one. None of the other guys do. So if you want to look up a contact at Goldman Sachs or Morgan Stanley or whatever, Godel lets you do that. Bloomberg lets you do that, but the other guys don't. Okay, bonds is something that is really important that is generally not available. TradingView added bonds recently, which I was really impressed by, but Godel is rolling out bonds soon. I haven't used TrendSpider. Finviz is not a terminal. Finviz is very far away. Very far away. So privates, literally nobody has them but us. So that's kind of neat. Quantitative, I would say nobody has them. Bloomberg, maybe a yellow. There's literally only 4 terminals. You guys are suggesting shit tools, okay? You guys are suggesting websites. They're not terminals. Yeah, that's actually a good point on crypto. Crypto, we have a crappy... Our crypto product is pretty crappy, actually. TradingView has a decent crypto product. But, TradingView is kind of a joke in a lot of other ways. Yeah, even a quote monitor is actually... These guys... I would say it looks like this. TradingView doesn't even have a quote monitor, which is kind of sketch. Yeah, sell-side research. That's probably the biggest one. We're actually more of a yellow here, but... Yeah, so... What else? Yeah, think tank, please do. Please do send me those things. Yeah, we're still early, obviously. We just started the company. Yeah, Broker Connect is interesting, but like global user data is something that none of these guys have. But we're just starting out on it, and that's kind of neat. So, like I said, I can tell you. I'll show you something interesting here. We don't have backtesting. We have vector search, which is kind of a neat thing. Yeah, alternative data is pretty important. We're actually not there yet, but we are planning on it. But here's my internal Grafana, and yeah, so there's 500 users have connected their brokerage accounts and $79 million. So that's pretty neat. And soon we'll be able to show you like who the largest positions are and things like that. Interactive isn't a terminal really. It's just it's an order entry tool. It has some research. It's not bad, but it's not really. So some alt data at CapIQ, FXet maybe. Yeah, I think the conference call stuff is useful. I wouldn't call that an advanced feature, but you know, it's something that we're gonna add, but it's definitely real news. I think there's like, this is actually something a lot of people fuck up. You know, news is hard to do right, and like TradingView fails completely at news. Interactive is so good, yeah. Well, brokerage, most terminals don't really do brokerage. So, you know, Bloomberg has a feature. Really none of these guys, nobody else really does. We may do brokerage at some point, but it's not really, you know, too important. Yeah, I'm familiar with them, Julie. We're working on it. We're definitely going to do it. So that's kind of how I think about it. Obviously, I'm kind of painting my company in my best light. You can connect any broker to Godel, actually. Oh yeah, we're gonna do something fun that is kind of maybe it's kind of retarded, but we're working on sort of user rewards and user contests. So we have we're gonna give out money to like the best trader on the platform. And then we also have a hedge fund who wants to back our best traders and give them capital to trade. So it's definitely an interesting thing we're working on there. Yeah, we're doing annual in a few days actually. But how you pay us is not really a feature. Yeah, let me see what else. Something really unique here. I mean, time and sales is available in most trading terminals, but it's not really focused on in lots of other ones. So we're going to increase our time and sales kind of capabilities. It's for retail and institutional. You can't yet, Liam, but we will soon. We don't have the trading competition open just yet, but we will. I'm trying to see how much money I can offer for the user. Yeah, Godel has options chains. So Oman is the Bloomberg symbol. The point of the terminal is that it goes really fast. So like I can move this window around with my keyboard. I can open it. I can close it. So Oman is our version. Now you can also do OVME, which is a Black-Scholes calculator. So I can do a custom OTC option. So 50 days to expiry. I don't know what the price of the underlier is. Let's say 191. Strike price is 250. There's the implied vol. There's the risk-free rate. You can see what a theoretical put call would cost. So there are other options calculators out there. It's not a big deal, but we're adding some interesting like historical vol tools and things like that. We don't have prediction markets yet, but we will add it. Supply chain analysis is pretty simple. We're adding that. That's really not that impressive. I mean, most people know what customers and what suppliers exist for a company, but economic data we're adding as well. I don't think that terminal products are valuable for retail investors unless they're trading lots of money. We have a free version, and if you connect your brokerage, you get a discount, but it's really meant for people with big portfolios, not individuals. If you spend 6 minutes looking at a stock, it's not for you. We don't want you, in fact. But if you're serious about research and you have a big portfolio, then maybe. You can, Brandon, yeah. I want to make that a little easier because a lot of the news we have in the news feed is kind of cruddy. Didn't I ban you, Melancholia? You're wasting my time. I don't know. You can see from the average user here, 778 million, 466, that's 200 Gs almost. Some of these are people connected empty accounts, but 200 on the low end, I would say. No, we don't have Cedar. We gotta add Cedar. Yeah, the price is gonna go up as the product improves, yeah. But we're gonna try to keep it affordable for retail because we want to harvest your data. I mean, if you don't mind giving us your data, then we'll let you use it. Options have time and sales, yeah. That's the catch. Well, if you agree to give us your data, we're going to do whatever we want with it. We're going to strip it down, and we'll always keep it anonymous, but we're definitely going to do things with it. That's the catch. You can pay the full price. I don't care. You don't have to give me your data. I want that data, though. Soon, I hope that we can pay people to use Godel. That'd be even better. But Robinhood sells your data too, as does every other brokerage. So don't get it twisted. Everybody's selling your data. No lock-ins ever again. No, sorry. You missed a chance. You had your chance, but you blew it. Oh, why, Quantum? Why? You're hurting me. No, it's not payment for order flow. So it's not like real-time trade data. Because once you put the trade in, there's no way for anybody to front run you. It's more... So it's not payment for order flow, execution flow, or anything. It's more analytics. Yeah, we have a mobile Buzz. But it's not an app, it's just our website. Oh. What's OpenAI doing? Oh, we got news on OpenAI. Equity of 130 for OpenAI. The recap.
OpenAI has completed its recapitalization, simplifying its corporate structure. The nonprofit remains in control of the for-profit and now has a direct path to major resources before AGI arrives. The nonprofit, now called the OpenAI Foundation, holds equity in the for-profit currently valued at approximately $130 billion, making it one of the best resourced philanthropic organizations ever. The recapitalization also grants the foundation additional ownership as OpenAI's for-profit reaches a valuation milestone. The OpenAI mission, ensuring that AGI benefits all of humanity, will be advanced through both the business and the foundation. The more OpenAI succeeds as a company, the more the nonprofit's equity stake will be worth, which the nonprofit will use to fund its philanthropic work. The OpenAI Foundation will initially focus on a $25 billion commitment across two areas: health and curing diseases. The OpenAI Foundation will fund work to accelerate health breakthroughs so everyone can benefit from faster diagnostics, better treatments, and cures. This will start with activities like the creation of open-sourced and responsibly built frontier health datasets and funding for scientists. Technical solutions to AI resilience. Just as the internet required a comprehensive cybersecurity ecosystem, protecting power grids, hospitals, banks, governments, companies, and individuals, we now need a parallel resilience layer for AI. The OpenAI Foundation will devote resources to support practical technical solutions for AI resilience, which is about maximizing AI's benefits and minimizing its risks. This builds on the $50 million People First AI Fund and the recommendations of the Nonprofit Commission. Mission at the center. OpenAI was founded in 2015 as a nonprofit. Its mission is to ensure artificial general intelligence benefits all of humanity. Today, OpenAI remains a nonprofit dedicated to that same mission. The OpenAI Foundation controls the for-profit business, which was established in 2019, keeping our mission at the center. The for-profit is now a public benefit corporation called OpenAI Group PBC, with the same mission as the OpenAI Foundation, which ensures the company's mission and commercial success advance together. Learn more about our structure. This recapitalization maintains the strongest representation of mission-focused governance in the industry today. This recapitalization was completed after nearly a year of engaging in constructive dialogue with the offices of the Attorneys General of California and Delaware. We made several changes as a result of those discussions, and we believe OpenAI, and as a result, the public we serve, are better for them. The path forward. The OpenAI Foundation and OpenAI Group will work in concert to advance solutions to hard problems and opportunities posed by AI progress. This includes making intelligence a tool that everyone can benefit from, building safe and aligned systems, turbocharging scientific discovery, and strengthening global cooperation and resilience. We believe that the world's most powerful technology must be developed in a way that reflects the world's collective interests. The close of our recapitalization gives us the ability to keep pushing the frontier of AI and an updated corporate structure to ensure progress serves everyone.
Okay. So, man. Thank you. No, the free version you can use forever.
Top news alert. Microsoft OpenAI reached new deal valuing OpenAI at $500 billion.
Microsoft owns 27% stake. Oh boy. They made 10x their money. $27% is better than I thought. Sam did a good job negotiating. They thought they were going to get 33%, but it's still a lot. I would have given them 5%. Thanks for the money, bruh. I still have to look into Biohaven. Maybe I could do that today. What GTC is this? There's like 80 million GTC conferences. It's like a GTC every month. Sorry, I have lots of stuff to do, so every now and then I kind of just go silent. I am running a business and I'm focused on that and not always focused on stocks. Yeah, I mean, Capricorn drug doesn't work, so they rejected it, and then we're gonna get new Capricorn data soon, so we'll see what that looks like. Thank you. Thanks for understanding. But I'll be around all day. No, the Capper phase 2 does not show anything. Don't be fooled. What's that, Surge? Hey. We got like 50 different service providers, immigrant. I don't think Sarepta will move on Capper, no. I know, I would hope it goes to 8 or 9. Appreciate brand new me. I don't think so, Ryo. But we should do that. You're talking about like an earnings calendar. Yeah, Sarepta's probably going to double as people realize the. Okay, I think I have a good idea for events calendar. Rentec did not lose 15%. Reef lost 15%. Big difference. Big difference. Big difference. I don't know anything about IRBT, to be honest. Thanks. Appreciate it. Don't know twist. I think there is no B100, right? It's just B200. Grokpedia is out? That'd be cool. I don't think EQ earnings will mean anything. No, probably not. No, I don't trade IBIT. I don't trade Bitcoin at all. Yeah, I try not to buy too near-term puts, but a month away is not too bad. If you constantly roll it. No Bitcoin for me. Yeah, I'm kind of bearish on Bitcoin, but I don't have a trade on or anything. No pre-populated templates, no. We should do that though. Cold in here. Well, Bitcoin is why not believe in Bitcoin? Well, it is fake. It's fake money. That's a start. Yeah, the cryptography is probably flawed. Yeah, it's slow. Yeah, that's right. It's not backed by anything. It's not nation state backed, which is good and bad. Well, RSA and Bitcoin have nothing to do with each other. Bitcoin uses a mathematical object known as the elliptic curve. Gold is sort of fake too, which is why it often underperforms. Not in love with gold either, exactly. Precious metals are kind of there's no easy perfect asset, that's for sure. Non-productive assets are hard to value. You've said it. That was the best. Well said, Shebev. Pretty much all non-income producing assets. And that includes real estate, by the way. Real estate is a non-productive asset. I would define a productive asset as an asset that takes capital and returns income. Everything's sort of about the marginal buyer. Well, I guess not. Non-productive assets are definitely about the marginal buyer. You're right. It's cold in my office. Well, yeah, cattle technically cattle's a productive asset. You put food in, you get milk out. Maybe some meat at the end. Some productive assets are basically unproductive. They're productive in name only. Like, speculative. There's some speculative assets that are, basically fictional. Yeah, I mean the goal. It's sort of like dividends. I mean, the theoretical goal is every company pays a dividend, but practically it's gone out of favor. Okay, market fading here a little bit. Hope all my beta goes for sale. Holding these balloons, holding these balloons, holding these balloons. The tulips. The tulips produce seeds. You plant the seeds to get more tulips. Oh, wait a second. That sounds like bad tulipnomics. Tulipnomics. I don't know, Dan. I'm not as heavy into the science as I once was. I have to hire a biotech analyst and start getting Yeah, Tom, it's good business. Networking is now like 20% of NVIDIA revenue. Consensus definitely has the revenue slowing into next year. Fiscal 26 ends in 2 quarters, so halfway done there. I've got 295 for fiscal 27, which was pretty wild, but the streets moving up to that number. So I was at 295 when the street was at 248, and now the street's at 280. My DCF says 235, but the DCF implies big earnings growth and permanence for NVIDIA, which is hard to guarantee. If you take away permanence, it's very hard for the company to be worth a lot. And I was talking to my baby moms, my wifey, last night, and it was like, the hard part about business is not so much the growth. It's kind of easy to grow. Well, it's not easy, but outfoxing your competition for 5 years, 10 years, you can do it. But can you actually, over 50 years, sustain, huge amounts of growth? In the short run, the market may believe you. But if you wait 5, 10 years, maybe 20 years, even the slightest hint that you're not going to sustain those earnings, or they'll reverse. Timber. Well, thanks for coming to my channel, but that's enough of that. I call her my baby moms. It's my baby moms. I don't know why Spruce has been declining. I mean, it sounds like you might be over invested. For me, it's like, give it a year. Should get to my target price, but I'm not watching it every day.
World of the very small, the atomic and the subatomic.
What the fuck is this? Why is my YouTube
Atomic levels, and there's a whole different set of rules that govern the day down there called quantum mechanics. And so when someone says quantum, it's taking advantage of those very strange quantum mechanical properties.
What?
Hi.
What's going on here? Jensen Huang, everyone. Oh, he brought us water.
Thank
That's
you.
what he does.
Yes, we do.
Thank you.
It's very important to stay hydrated.
What is this mumbo jumbo about quantum? Superposition,
Entanglement. Entanglement.
entangling stuff. Like, this is just mumbo jumbo.
Hey,
Mark,
good to see you.
Oh, he doesn't shake.
Yeah.
He doesn't shake the quantum guy's hand.
always a positive.
Or did he?
From Denny's to
Thank
DC.
you.
From Denny's to DC.
Thanks for being here. Wow, this is
Yeah.
something
Thanks
else.
for having us.
It's incredible.
Great game show.
It's been an amazing morning. And this panel, I think, saving the best for last, Jensen. So, you know, maybe ask this. You caused a kerfuffle. Last year when you made some comments about quantum. Anything you would like to revise, you know, as we're about ready to launch our quantum panel here about how NVIDIA thinks about quantum?
You know, I gotta tell you, I'm afraid to say a word. If I just said quantum, the stock price goes up. Quantum, quantum, quantum. Bye. Here, listen. Listen, the work that we're doing together is really important, obviously, and I think the message that what I was trying to say is that quantum and classical computing really needs to work together so that we could bring in the usefulness of quantum computing. And it's becoming very clear that the two industries really need to work together as one. And that quantum classical computing, quantum GPU computing could really help solve a lot of very sticky problems, very challenging problems associated with quantum computing. And the ecosystem and ourselves, we're doing some amazing work. It remains incredibly hard. I mean, the work you guys do, it's deep science. You know, we do deep engineering, they do deep science. And so I'm excited about the work that we're doing together. I won't ruin it by telling you guys what it is, but this doesn't work.
Now it does.
Yeah.
Now it doesn't.
It's okay. No, this is about you guys. This is about you guys. And apparently, I want to thank everybody for coming to GTC in Washington, D.C. Yeah. So the original plan, I'll be honest. The original plan was President Trump was going to be in Washington, D.C. And so we brought GTC to Washington, D.C. The administration's all going to be here. And then literally 2 days ago, President Trump said, Jensen, could you be in Korea today? And I said, I would love to be in Korea today, but I came to visit you in D.C. And so anyways, we're in two sides of the world. But anyhow, he wishes all of you well. He's going to see me in a day. And we're gonna go and support the president in his tour through Asia. You know, he's our president. We want him to be enormously successful so that America could win and America could win around the world. And so, anyways, I want to thank everybody who's here working in D.C. Thank you for your service and thank you for coming to GTC. All right, great to see you.
Thanks, Jensen. Take care.
We can't wait to hear more. I mean, we said last night we are in Washington. We've heard on the panels this morning, so maybe we'll just jump to this and then we'll come back, Matt, to that.
Yeah.
But, you know, there's an extreme need to accelerate AI. I think Jensen's been at the forefront, NVIDIA leading the charge with the president, the White House, and Capitol Hill. But we also see a lot of doomerism. You know, you guys are in what I would call long haul, you know, investigation, discovery, and execution. Talk to us a little bit about the importance of having Jensen leading the charge and NVIDIA leading the charge to your businesses that require decades of innovation, and maybe how you're partnering with NVIDIA to make that happen. Matt, we'll come back to you on that.
Absolutely. Well, I mean, we have looked to NVIDIA as a trailblazer of how you bring deep tech out into the market in a staged, commercialized way. And so as we've thought about bringing quantum technologies out into the market, we saw them point their GPU engine at graphics to start, and then at crypto mining, and they always found the next thing until the crown jewel of large language models came around for them. And so the way we've thought about commercializing quantum is by pointing quantum at areas where there is true quantum advantage already, like timekeeping, and then quantum RF sensors and antennas, and on the trip to that crown jewel of quantum computing that will do things that classical computers can't do. And so we've really used them as what we've modeled our strategy against. And so Jensen's led the way in many ways, and including one of them is how to commercialize deep tech.
Right. Absolutely. Do you have any comments on this, George?
Well, I totally agree. I think that another early stage thing that we can do that roughly involves quantum is natural computing, where the
George
best
Church?
simulation of a particular system is the system itself. It's 100% accurate, and there's certain systems where we have the synthetic ability to make them even more cheaply than we can compute. But they're definitely quantum. They're very complex systems are possible.
For sure. So, Anirudh, you could have been on any one of these panels, all 5, given how broad your company operates in. But I do want to ask you about how is AI accelerating all the way going from the chip to the entire system.
baby?
And as we heard from our panelists before you, also into electrical and cooling systems and the power grid.
Yeah, first of all, great to be here. And so for people who are not familiar with Cadence, Cadence basically makes products to design chips and electronic systems.
Cadence,
And we
Chad.
have a long history of working with NVIDIA. We have worked with NVIDIA for more than 20 years. And it's remarkable to see, what NVIDIA has become and, under Jensen's and what it will be going forward. Now, I think the key thing for chip design and also now chip and systems are merging together is there's a lot of deep science in it. So basically our products are software products, which is a combination of CS plus math plus physics, okay, and applied to chip design and system design. And the whole stack needs to be optimized. And what AI can do is it can provide the next level of innovation, the next 10x productivity improvement, because chip design itself is exponential. So if you look at chips now, by 2030, the chips will be 10 times bigger. The systems will be 30, 40 times more complex. So we need the next level of productivity improvement that AI automation can provide. So to me, it's a combination of AI, the basic science, the ground truth, and accelerated compute. This is what I've called for a while the 3-layer cake, and all 3 layers of the cake have to
mention quantum.
AI, the ground truth, that's still very important. And then accelerated computing. And the interesting thing with accelerated computing, especially, I always wanted for a long time, combination of CPU and GPU. And NVIDIA has fabulous GPUs, and GPUs have become much more general purpose as NVIDIA has latest generation. But with Grace Hopper and now Grace Blackwell, the fact that CPU, GPU are close together gives a very great foundation platform to build science and AI on top of that.
But before we go to the next one, maybe just an announcement to everybody in this hall. Jensen is beating you over to the keynote. So I've been advised to tell everybody in this hall they need to make their way over to the keynote to grab your seat so that Jensen's not over there alone. Meanwhile, we're going to continue this conversation. One of the things, that has been a promise for a long time is how AI or how technology is going to advance human genomics, advance drug discovery. And I would say that there's been a lot of promise, and there's probably been less success than the world might have thought 20 years ago in terms of the transformation that would come. It feels to me like we've been laying down the tracks, right? The groundwork, the primitives for these big breakthroughs. And so my question to you is, are we on the verge of really solving problems that we've been talking about for the last 25 years? Yeah. Do you think the cycle time on discovery is about ready to change because of where we are in AI? And, anybody who wants to chime in, but we'll start here.
Right, so I think we're at an inflection point, absolutely, and it's for the reason you mentioned. The tracks have been laid down. The company's name is Inflection. There have been advances just in the last few years that have made it possible to achieve liftoff. If you think about the problem of drug discovery, and that's a famous biopharma guy. Today, when you start working on a molecular target to make a drug, make the drug, take it through clinical trials, and get FDA approval, on average that takes 13 years. 9 out of 10 drugs that enter clinical trials fail.
I agree. AI drug discovery is
bullshit. The overall cost, including the failure, is about $2 to $4 billion per drug, and it's not improved in the past 20 years. And that's because drug discovery is still very artisanal. A lot of science, yes, but a lot of art, intuition, empiricism, trial and error. And at the highest level, AI, the promise of AI is that with the right kinds of data and the right amounts, we should be able to transform this from an artisanal endeavor into an engineering discipline with much higher success
it's
rates.
kind of an engineering
and shorter
discipline,
timelines.
but okay.
I think in terms of the inflection point, if you think about there are multiple applications of AI in the drug discovery platform. One is at the level of
I mean, we've been using AI in drug discovery for a long time. It's just not
trials,
kind of AI we're talking about.
The advances with large language models are already being put into action. We're seeing companies across the world implementing this to improve the efficiency of recruitment, identifying patients, filing reports to the FDA. All of those things are being accelerated in a dramatic fashion. The second area is in molecular design that's been touched on in the movie, and you talked about it, where instead of screening for drugs, we're designing drugs. Just as you can ask Sora to make a movie of two puppies playing on the beach, you can take a protein and say, I'd like to make an antibody, a drug-like substance that attaches itself in just the right way, and have the AI design it. A lot of action there, but the advances are recent. The Nobel Prize a year ago went to two groups, the DeepMind group, Demis Hassabis, John Jumper, and David Baker, our co-founder, for advances just in the past few years, AlphaFold, RF diffusion, RF antibody that make it possible. So we didn't have those technologies 10 years ago, even 5 years ago, so that's prompting that acceleration. And then the last area, in some ways the hardest one, is understanding human disease, human biology and human disease, and getting those insights to figure out what should we make drugs to, and who are the patients who are going to respond. AI is just entering that area. That's also, I believe, going to build over the next few years. But we're seeing acceleration, very rapid acceleration in the first two that wasn't possible until a few years ago. And we're going to see increased acceleration in the third.
George, same question to you. Are we on the verge of a new cycle time in terms of discovery? Is the promise, I look at discovery and invention, and these are nonlinear systems,
yes,
right? And it feels like we're at a moment, because of all the technologies that we're talking about, that a lot of this promise is going to come to bear. What are you seeing through the lens of Lila?
Yeah, so this is definitely an amazing moment. There's the intersection of exponentials that have been occurring both in computation and in biology. For example, 20 million-fold reduction in cost of sequencing. And that's something we use not just to study the populations, but to guide experiments, to interpret experiments, and so forth. Just that analytic tool. But our synthetic tools are also getting better. I mean, our confidence in having low toxicity.
What's up? What's up? Quantesla's here.
Our confidence in having low toxicity and high efficacy is making the clinical trials shorter. The record now, as far as I know, is baby KJ, which was 7 months from birth, diagnosis to cure with a gene therapy. And we are really actively using not just the dichotomy between screening and analysis and prediction, but putting them together. So you can use AI to design as well as you can, but then you make big libraries because there's some modesty that you can't necessarily design the perfect thing, but you can make these big libraries, and that combination is much more powerful than either one of them separately. So for example, at Dino and Manifold, we've made proteins that target the nervous system 100 times better, and they detarget the liver, where you can get toxicity and absorption of the valuable drug. So those are just examples. This is happening now. This is not dreamy stuff off in the future. Yeah.
Exactly.
So before I go to the next question, I have a public service announcement, and that is the pregame show is actually being broadcast inside of the hall. So as much as I'm sure you want to hear Brad and I and the guests, Jensen is a bigger show, and you want to make sure that you get your seat Thank you very much. Okay, now to your regularly scheduled program here.
Yeah, one thing I want to add on drug discovery.
Yes, please.
And Cadence has a molecular science division. We are working with a lot of the pharma companies.
Interesting.
Because a lot of the math and science is similar in chip design, which is very nonlinear to drug design. And something to watch because is how much of the work is done on the computer versus how much of the work is done in the lab.
Got it.
And if you look at like 3 big areas that I'm involved in, one is chip design, and there 99% of the work is done on the computer, and you get first time right silicon. Okay. Then the second part is system design, design of planes and data centers and cars. Okay, over there, 20% of the work is done on the computer, 80% is still done on the physical work. And then you go to drug design, molecular design. I think only few percent of the work right now is done on the computer, and most of it is done. That's why the design times are so long. Okay, so what happened in chip design is most of the work moved to the computer, and then you can do modeling, which is
that drug pharmacy dude, Martin. What's his name?
Martin Shkreli.
Shkreli.
What? Let's go.
You can do modeling, which is accurate. Then you do simulation. You can do modeling, which is accurate. Then you do simulation.
I'm on this quantum internet. It's brutal. I gotta swap to another internet provider. What the fuck? How is it this bad? I'm streaming, but I can't look at the internet.
Streamline and streamline and streamline and streamline and streamline and streamline and
Gotta throw this computer out the window.
Punt on any commentary on the stock prices on. And so we're not talking 50%. We're not talking 100%. We're talking.
I don't have a VPN. What are you, fucking crazy? Why would I have a VPN?
timekeeping, RF antennas, things like this, sensing. Qubits are really the keys to the kingdom in quantum. And this is one of the ways that AI and quantum are really going to interact and be tightly coupled.
I should go on
because
Hyperliquid.
AI helps us get to logical qubits faster. Because logical qubits are error-corrected physical qubits. So they're sort of these pristine qubits that you can actually use to do computation. So up until 2023, the world did not have logical qubits yet. We weren't even sure if we could get them. In 2023, we saw the first logical qubits. Today, Inflection and a handful of companies have logical qubits. We announced that we had 12 as of a month ago, and it's generally believed that about 100 logical qubits, you'll start to see quantum advantage in areas like material science. When you get to 1,000 logical qubits, you'll start to see quantum advantage in areas possibly like drug discovery, and as you scale those logical qubits, you'll see quantum advantage in areas beyond those. And so I do think this will be absolutely game-changing technology. I left a great career at a firm called Maverick Capital to come do this full-time because I see the opportunity ahead is absolutely huge.
So I have to ask George and Mark, I mean, you're using GPUs today. We'll call that, it's hard to call GPUs classical computing. I think that is CPUs. So CPUs to GPUs. How are you looking to quantum to help change what you're doing? Because quite frankly, if I look at the algorithms that they're working on and what they do, it would seem like there would be an opportunity, maybe not immediately, but maybe in the future.
Mark, you want to start?
Well, in terms of which kind of going from CPUs to GPUs to quantum computing, or what?
Well, we're going to have a world, I mean, listen, as we know, nothing goes away. We'll always have CPUs.
Right.
GPUs, and we'll have quantum, which will assist it.
So, we're like many companies like ours that are doing, applying AI to molecular design, AI to develop foundation models of biology. We're big consumers of GPUs, obviously, in what we're doing. There's certain applications where really having the power of quantum computing would come in very, very handy, in particular for molecular dynamics simulations, which right now require, basically much more compute than what we like to deploy. So we see lots of use cases where we could leverage that kind of technology. For now, we can run with the technology that's being made available by NVIDIA today.
I mean, one thing to add on quantum, and we work with a lot of the quantum companies as they design their computers, and quantum is very promising, especially for certain applications. It can give a huge speed up. So we are closely watching when it gets to scale. But I think future will be hybrid. I think CPUs are still important.
Oh,
GPUs
absolutely.
are phenomenal. FPGAs, custom silicon. So I think it's not an either or thing. Quantum will have certain big applications. It will give dramatic speed up. But all the other hardware platforms will work together to solve.
I completely agree with that. I think just as GPUs layered into the data center and enabled new capabilities of what we could do with compute, QPUs will start to slowly layer into the data center and just expand what we can do at with compute. And I think it'll result in more CPUs and more GPUs being deployed and sold because we'll be now addressing problems that just weren't able to be addressed with compute historically.
I mean, maybe one of the, as we begin to reflect on the day heading into the keynote with Jensen, in my world, the world of investing, the talk really is about, a bubble and whether we're ahead of ourselves. That's where we started the conversation. I think it's super important that we kind of steal people's minds for the fact that this is not a straight line up and to the right, as we look ahead. So as you take yourself out of the position of running your companies, but just as an observer of technology ecosystems over a long period of time, when you hear all of the deals announced over the course of the past many weeks, trillions of dollars of compute that's getting built, what concerns you the most, right? As you're running your company, as you look ahead, what do you think could upend us? What do you think might be that risk that causes this to slow down or us to get ahead? Are any of you concerned about, kind of the dark fiber and the GPU overbuild that you certainly hear talked about on CNBC every day?
Well, let me start. And I mean, what is promising for me to see is that, you know, there is still a lot of demand from our customers, the big companies, to build more and more compute. And the way I think a lot of people don't quite grasp that there are multiple phases of AI in my mind. And we are in the Horizon 1 or first phase, which is the infrastructure build out, okay? Build out for on the cloud, on the edge. But there is Horizon 2 and Horizon 3 phases, which can be even bigger. So the first phase is infrastructure, LLMs, you know, and if you look at that first phase, I still see, talking to all the big customers, years of growth in compute and AI capability. But what is even more encouraging to me is phase 2, which I've always said for years is going to be physical AI. You know, AI is not going to be restricted to the cloud and to software applications. It will move to the physical world, which is cars, planes, drones, robots, and that could be trillions of dollars of monetization. And then phase 3, even though we are already doing science now, but science is AI to me is the Horizon 3 application with drug discovery, with material science. I mean, these are trillions. So I think we are only in Horizon 1.
Yes.
And talking to customers and partners, Horizon 1 still has years of legs. And then you add Horizon 2, which is physical AI, Horizon 3, which is sciences AI. I mean, this is a long way to go still.
It's a great framework.
And I think we're seeing the same thing in our field. In phase 1, the availability of the algorithms and the compute means that it makes sense for us to try to generate data at scale. Previously, we couldn't have made use of those data or interpreted them in the right way. So we're going to have that build out. We're going to see the permeation of AI in all aspects of the laboratory. That's how people will analyze their data. It's going to become just routine and baked in. So I see steady growth, and especially with automation of the kind that George is thinking about. But also, I think it's important to try to set expectations right. It currently takes 13 years to go from starting a drug discovery program to having FDA approval. We're not going to get it down, that whole 13-year process, down to 2 years. Right. Can we get it meaningfully down to 10 years? I think we should give ourselves the ambition that over the next 10 years we cut it in half, and we cut the attrition in half. Those would be huge gains in terms of bringing life-saving therapies to patients. But we have to be realistic. Some of the AI companies that started before we did are already going very quickly from starting a project to getting into clinical trials. One of the ones, there's one that announced recently, within 2 years, they went from starting a project to getting clinical trials. Normally it takes about 5 years to do that. So I think we're going to see meaningful improvements, but you also have to be realistic.
But we already have an example of 7 months. Yeah. So let's not say that it's that far off necessarily. That's right. And to the hybrid strategy, I think we already energy is going to be a big thing. And if we look at biological intelligence, the energy consumption there is 12 orders of magnitude better if you talk about petaflops per watt. And so we need to look at that as an example. So we'll have hybrid systems. We've already made single molecule transistors in a CMOS system. We published this 3 years ago. We're going to see more of that, molecular electronics. So hybridizing with quantum, which is quite different.
Well, looping back to Brad's initial question, which is the bubble bearers, it sounds like, and I say this tongue in cheek because I'm an optimist, is you could do some pretty useful things with 100x or 1,000x more compute. I mean, you could make life-saving drugs out there and things that can literally cure diseases that have never been cured before.
I mean, I think the way my mental model is there's an enormous investment cycle going on here, and a return will need to be earned on these investments. And so I think it all comes down to, do you believe a return is going to be earned on these investments? And I guess you could say, are the investments leading to useful things? And it sure seems like they're going to be useful. And so the question is, what kind of return are they going to earn on these investments? And so
and these multiple phases, we reinforce the previous phase. So if there's infrastructure AI, physical AI, sciences AI, in physical AI, when we deploy AI to robots or cars, of course, the car itself has an inference chip, like in a Tesla or in a robot. Yeah. But the model, the new world model, still has to be trained on the data center. So not only the infrastructure AI is strong because of software application, When physical AI happens, it reinforces the data center. Same thing with sciences AI, it will reinforce the data center. And also in medicine, there'll be a lot of robotics that helps. So these layers not only are good by themselves, they reinforce the previous layer.
Yeah. Gentlemen, this has been an amazing conversation.
Hey, welcome back. I am so happy for you. How did it feel walking out and like, get your hands off me? Yeah. That is so funny. That's hilarious. I didn't know you were projects. Okay. I think that was a little bit of an exaggeration, but you know, that's you know how jealous that those stories get stretched out. But over the course of my jail career, many, but I think. Are you there? Hello, hello. Motherfuck.
Your AI.
What's going on here?
And we have Aki Jain, President and CTO, Palantir U.S. Government. So, great to see everybody here. So, Young, I want to ask you the first question. First of all, my relationship with Foxconn goes back to 1995. And I don't know if they call that experienced or old. But you are one of the biggest manufacturers for all precision goods. From smartphones to hyperscaler data center equipment and pretty much everything in between. Talk to me how AI and robotics is transforming what Foxconn does.
Okay, first of all, thank you for having me here. This is a very great event for technology companies these days. You know, Foxconn is the largest manufacturer in the ICT industry. And we used to be very much labor intensive. And then we transformed it to automation intensive. With new generative AI technologies, we think the AI intensive manufacturing is coming. And with this new technology, this is new and disruptive, we'll have to work with industrial leaders or technology leaders like NVIDIA, Siemens, and the friends at this table together, to be able to catch up and apply the new technologies to our manufacturing facilities. And currently, we are building up factories, here in the States, in Ohio, Texas, Wisconsin, and California. And we think, the AI era is coming.
Yeah,
and
you guys
I call
can hear.
this Industrial 5.0.
That's excellent. Peter, your company is known for being in all of the connective tissue inside of manufacturing. And I'm curious, how is AI making manufacturing in the United States more competitive? Because that's a big talk, particularly here in Washington, D.C. And quite frankly, it has a lot to do with, and Brad pointed this out in an earlier segment, even national security.
Right. So we believe that AI really will be a key driver for the establishment of manufacturing yet again in the United States, which is going to be smarter. So we think of it as more of an AI native factories that we want to build. So it starts with the sensors, right? I mean, the sensors that you all carry and that we all carry, we love the data. And because we got so many sensors now everywhere, humans cannot make sense out of this anymore. So therefore, you need to automate that. And so as we build now factories, we build them always twice. We build them first in the digital world, and we optimize them, and we see how you place the machines, how the material will be flowing, how humans will be interacting with machines. And then we optimize them over and over and over again until we finalize, think, this is great. Then we build the real thing, so with the real factory, but still you got the real one and the digital one, and they talk to each other. So whenever you have like a supply chain glitches that we used to have, remember the semiconductor shortages, you actually can go to your digital model and you can look at it and say, what if actually this part is missing? What will the implication on, of course, on the shop floor? And that gives you unprecedented speed, it gives you unprecedented productivity, and of course, sustainability and energy efficiency. And I think this is vital as we think about the next generation of manufacturing blueprints here in the United States, which is very labor constrained because we don't find enough people to fill all the factories. We have to automate that, and Siemens is a key part of bringing manufacturing back to the United States.
Makes sense.
Hey, Brett, a lot of people talk about Tesla and Optimus, and what they may not know is that Figure AI has emerged as a startup, from a small startup to a real leader in humanoid robotics. We heard you earlier this morning jamming with Jensen about the things you're doing with NVIDIA to put you at the front of that pack. Tell us a little bit about Figure, where you are, and how the relationship with NVIDIA is so potent in really launching you into a leadership position here.
Figure is trying to basically build humanoid robots that can do everything a human can. You can't code your way out of that problem. I mean, every joint it's a motor, can move like 360 degrees. So you basically have 360 to the power of 40 equals the number of states the robot could possibly, like the basic body positions.
Yes.
It's like more than atoms in the universe. So it's just, you have to solve this with neural nets. And so for us, we have this like kind of phrase we use where we're trying to give AI a body and to do everything a human can. So that means everything from pre-training, like we have to basically build like large-scale data collection efforts of human-like data to do training. We use NVIDIA there. And then that means at test time, when we're running policies on robot, we're doing inference on NVIDIA GPUs on robot without any network connection. So we can basically run robots in full end-to-end situations like doing work without any network, outside network. So for us, we think of ourselves like an AI business. We happen to be building like these physical agents that are out in the world, like similar to web agents. We're basically just like in the physical world touching things. And NVIDIA has been a very significant partner and investor of ours, and I think they will be significant in the future as well.
And you guys today, just give people a sense as to where you are. You know, when did, you know, we heard 1 million, robots out at Amazon. Like, how should we be thinking about how many humanoid robots you guys are going to be producing, 2 or 3 years out?
I think, to be candid, the problem that the entire space feels for humanoids is we have to solve like a general purpose robot.
Yeah.
You have to get to be able to like just talk to it and have it do anything you'd want it to do in unseen locations. That problem is not solved. That problem is 10 times, 50 times, 100 times harder than making a humanoid robot.
Yeah.
In my view. So the hill we need to climb, the hill we're trying to hill climb now, is how do we build a horizontal AI stack that can do everything a human can. And quite frankly, we have robots that are working in the commercial market as of right now, like to this very moment. And it's been really good for us to get those lessons learned, but it also gave us insight to build like what is the right technology stack to go build. And that technology stack is like end-to-end deep learning. And so I think for us, we're trying to hill climb that problem. In parallel, we've now announced BotQ this year, which is our basically high-scale manufacturing facility out in California. We do all final assembly testing and robot shipping from there. And that problem is hard. It's more like a consumer electronics manufacturing problem, but it's not, it dwarfs in comparison to solving a general purpose humanoid robot, which is just like on the surface, just like an incredibly hard problem. It's tractable, it's an approachable problem, but that's the problem we need to solve first. And then from there, we need to figure out how to manufacture at scale. That's like heavy automation. We need robots in the loop for end-to-end manufacturing. And we're doing it now in-house. So we figure out how to build MES systems, how we build lines, how we do end-of-line testing, how we deliver it to the customer and make that better and validate it. So we're basically trying to get good at manufacturing while we're trying to solve the problems of like, how do we basically solve general robotics?
Yes.
Yeah.
Aki, Palantir, I heard Alex say the other day, Alex Karp, of course, that you're solving the ontology problem that sits between silicon and, and getting useful outcomes for companies, for businesses, for physical intelligence. Talk to us a little bit about how you think about the role that Palantir plays in, bringing us from the promise to reality.
Yeah, absolutely. So if you go back to the core of what Palantir is all about, you have all these data systems, you have ERPs, MRPs, random software that people have built in the ecosystem, and all those kind of systems solve a specific problem. They have different security frameworks and whatnot. How do you provide the ergonomics, whether it's for an autonomy stack, whether it's for a factory worker, whether it's just for a human to actually answer questions about that business and optimize it? And that's really what the ontology is. It's kind of that agility layer. Your different data stacks integrate with it. They provide the security, the privacy, other controls around it, and they provide the ergonomics, the AI yet. When Brett's done, the AI will be able to walk down the hall, and kind of sit at the water cooler and learn things about the organization, learn things about the IP, learn things about the processes. But right now it can't, right? The way it can is actually interacting with APIs. And so the ontology ends up serving as an SDK for the AI, for the agents, for the models, whether the awesome NVIDIA open models, Nematron, Cosmos, some of those capabilities, or the proprietary models. And Foundry and AIP, on top of the ontology, provide the ability for humans to orchestrate those models to achieve goals. So at the end of the day, kind of the core insight is if you reframe the data, which is what we do, into the ontology, you can reframe the operations of a factory, an organization, kind of any process at scale.
Maybe, you know, I'll start with you, Aki, on this, and we can go across the group. You know, we've talked a lot today about open models. I think NVIDIA's contributed more to these open source libraries than any other company on the planet. We'll hear more about that later today. What do you see, you know, really being employed in industry today, right? We obviously have these frontier labs that are producing these incredible models. But what do you see in terms of, you know, the hybridization, maybe the ensemble model approach, maybe, you know, some Chinese open source models that you see being leveraged by US companies, et cetera? I'd be curious what you see out there on the front lines.
Yeah, well, I think right now, at least from Palantir's perspective, both across, you know, half of our business is commercial, half of our business is global government. And what I would say is, look, we always start with the big heavy cloud model from the frontier lab companies, and there was proprietary models. I got to be honest, they're moving so fast and they're so effective. So we use them, you know, to solve any problem is the first thing we try. But we're finding more and more, especially as we move to the edge, as we're thinking about inferencing at the edge, we think about the need to sort of take those models, train them on bespoke data, and then move that towards kind of more of an edge inferencing architecture that solves specific problems, either with a small language model or even something that maybe is just a traditional machine learning model for a lot of problems where data becomes critical. So we're seeing the trend of open models and the ability to take those models, quickly refine them, and kind of get to something that solves a specific problem at a low swap is being really critical.
Yeah, I would concur. This is it usually starts horizontal. The horizontal ones are more open and by nature, but once you get into the use case specific applications, then actually they become more closed because you have to retrain. So as an example, we are doing a model that helps to do machine programming. Right? In the US, we're going to miss 2 million people by 2030, and we don't find the people that are skilled to do that. So to program a machine is a very specific code, and so we take a general language model, and so a large language model to apply it, but then we do all the racks, all the training, retraining of it in order to make this work, and then we are held liable for actually really that this works. So therefore, you need to close it to some extent that you get a little bit of a control over what the quality and the results are.
Yeah. Another line of question I'm interested in, you know, we, again, back to this question about the global AI race and the reindustrialization of America. You all have a role you're playing in that reindustrialization. Foxconn has made some major announcements about investments it's making in the United States and frankly, about data centers that you're building in partnership, you know, with NVIDIA around the world. Talk to us a little bit about how you see your role in the reindustrialization of America.
Yeah, based on our experience in terms of the level of AI intelligence for the manufacturing, and we found there are 3 levels of intelligence. Level 1 is for the simple and fixed operations. Level 2 is for simple but flexible operations. Level 3 is for simple but complicated but flexible operations.
Right.
Now, with these 3 levels of intelligence, it requires large compute power to do the training and the inferencing. And with that, that's why we're building a lot of AI-related facilities in the States, as I mentioned, from Ohio to Texas to Wisconsin and California, in order to support the demand for this compute power. But besides the compute power that is needed, we also need talented technicians and engineers to apply and to use these technologies. And that's another challenge that we're facing. That's something that we will have to do together with the government to have education that is steered towards this. Okay.
Great point. Brett, I know that, you know, you and Elon are leading the charge on robotics being built in the U.S., right? And obviously China famously has some leads in autonomy and in robotics, et cetera. Handicap for us, if you will, how you're feeling today. What's your level of confidence that we're going to be able to compete effectively on the global stage, both from a capability and a cost perspective in robotics with what's coming out of China?
I get this question a lot, and I have a very strong opinion here. I think what really matters today is we see the core, horizontal technology stack, both in hardware and software and AI, come together to build, general purpose, almost human-like intelligence in the physical world. That's the key unlock. I can't stress that enough. People are looking past that in terms of costs and manufacturability and all this different stuff. We're at a stage now where we got to go build synthetic humans. And it's incredibly hard. And I think what we are proud about at Figure is we've been able now to show these real pockets of long horizon intelligence done with neural nets. I think the shortcomings are that we couldn't put them into a house that's unseen today and do hours and hours and hours of work. We want to get there. We think we will get there. But we've seen all the ingredients of the puzzle pieces to be able to show that is going to happen. I think we've been leading that globally. I think if you're going to say okay, here's a robot now out in the real world that needs to run all day with low human intervention rates, low faults, we've been able to show that both in the commercial market and the work we've done in house. I think we are in a lot of ways miles ahead of other competitors we see in China in that aspect. From there, once that is solved or close to solved, it does become a manufacturing game. This is a consumer electronics manufacturing process. It's not an automotive manufacturing process, which means we have different piece parts and electronics that we need to fabricate. We need to do FATP. We need to do integration, EOL testing. We do all that extremely well. I think that is an extremely tractable and surmountable problem that you can do even at scale. I mean, we produce 1 billion phones a year, almost by hand in some way. We can definitely create millions and millions of robots, traditional consumer electronics manufacturing processes. But what is not solved is be able to do real end-to-end general purpose robotics. And I think the U.S. today, at least so I can say what we know at Figure, I think we're leading that head and shoulders globally. And we hope to continue to pull away. I'm going to be jumping on a flight right after this to make the engineering stand up end of day to try to continue that and pull ahead.
Yeah. Brett, there's been a lot of discussion, doubts around a general purpose biped robot that can operate in the home and in the factory. I mean, you got so many people. You dropped a video of one of your robots folding laundry, and I mean, everybody went nuts. Hey, I want one of those. But I'm curious, where does the technology have to be where you can confidently serve both of these markets? Maybe put one of them into Young's factory as well.
Yeah,
we can do a deal here on stage.
Let's get a deal.
Sure.
You ready to do a deal? Yeah, let's do it. There we go. Listen, I think one thing we're proud about is we have a robot running right now. And our first commercial customer, it's running a 10-hour shift as we speak. We've been doing it for almost 6 months now. We've gotten operational readiness there. It's running autonomously. We've been trying to track fault rates, human intervention rates per shift. Those have all been dropping. Performance has been rising every single month. So we now have a better line of sight to what it takes to launch a vertical job in a commercial world. What we're also trying to tackle, and what we found, learned a lot last year, is we need to solve the horizontal stack. We need to be able to build true general purpose work to put robots into anywhere in the world. So we've basically refactored our entire autonomy and AI stack from scratch. It's all done now end to end with neural nets. We think it's the only way to really scale, and it's done at the foundation level, so we can scale into any work. So I think maybe to answer your question more directly, we will see robots in the commercial workforce over now. And in the next year or two, we will try to put more and more out. We will try to get we'll try to get costs down, reliability of the robots up. We'll try to make it really real. In parallel, we're trying to solve a robot in a home. It's been in my home now for 3 or 4 months. Wow. We're doing small parts of this, small parts of laundry and folding and dishes. We now have to connect all of it together this tissue. We have to make it language conditioned so we can talk to it. We have to put it in pixel space. So there's a bunch of work in AI models and foundation work and pre-training that we have to go do. But we do see a path. It's a little light in the tunnel that we want to go at. It'll definitely be solvable. This in this decade. It'll be solvable hopefully in the next few years that we can have this work. So we're excited about that. But that is more of a car autonomy in a city versus car autonomy in a highway. They're very different. One's super unstructured, high variability, and a lot of the engineering challenge is proportional to that variability. So we're going head on at that problem. I would say you're going to see them in the workforce over the coming year or two. And then we will only launch a product in the home, in the workforce, at scale once we feel confident of the product.
Right.
We will not do it early. We will not teleoperate them in market. Like, we will not do any of this silly stuff. And I think that's maybe differs from other groups maybe in the space, but we are trying to build like end-to-end autonomy with low human intervention rates in this commercial end market. So once we're able to like really sell into your home, to Brad's home, we want to be really confident it's going to really work and it's going to be really safe.
Can I give you my credit card now?
We'll take it. Okay. We have a little machine in the back. We'll start. We're happy to punch it.
Aki, you guys have long been important partners to the U.S. government. We obviously have had a major changing of the guard over the course of the last year. A lot of people, including Jensen, have said that this administration is far more open to Silicon Valley and technology companies coming, sharing their concerns, sharing their complaints, and getting deals done.
Yeah.
Talk to us about how you're feeling about the state of, industry government partnership today versus what you've seen over the course of the past, many years.
Yeah, I mean, this is year 21 of Palantir for me, so I've seen it all.
Yes,
Just to be very clear.
Indeed.
It's like night and day, right? And that's not a knock on the prior administrations. I just think you had a particular status quo or way of doing
Top
things.
news
and
alert,
industry
U.S.
was
stocks
often
Wall Street
held
at record
bay.
highs after
And
Microsoft
Silicon
OpenAI
Valley,
deal.
frankly,
Apple
I
hits
mean, part of
$4
why we
trillion.
moved our headquarters to Denver when we went public was, very much a monoculture. You couldn't have disagreement. You couldn't actually discuss national security and the importance of national security to Silicon Valley and vice versa. And so I think what you see is kind of both at the intersection of the administration, taking on some really hard, gnarly challenges, at the same time as generative AI is coming through, is kind of, when you think about AI infrastructure, is kind of the way of the future. When we think about, how we're going to build things, how we're going to make sure we do reindustrialize and bring a lot more capability back to being built in America, you kind of have this perfect storm in the moment and the people. And what I've been incredibly encouraged by is the openness, right? Look, every administration gets something wrong, but that ability to say, hey, that doesn't look right, and to give feedback, and frankly, for people to take calls and kind of hear that feedback from industry and think through, hey, how do we make this great for government, for every American, and for industry, I think is unparalleled. And I think that that's kind of what we're seeing right now. I think it's also then kind of on the back of that driving a huge resurgence from Silicon Valley to say, hey, we want to be, I mean, Jensen said this so many times, if you're doing work in technology, you need to spend time in DC, you need to share what you're doing, and you need to talk about how it's going to help every American out there kind of as they kind of think through this. Otherwise, there's going to be a lot of fear, uncertainty, and doubt out there. Yeah. So we also have this responsibility as technologists now to kind of share that vision, share what we're doing, share how it's actually going to help, and kind of bring the American people along. And this administration is doing that in spades. So we're thrilled by it.
I am curious if you guys share the same experiences vis-a-vis Washington. I mean, I think one of the critical things this administration did was to name David Sachs, the czar of AI, so that there was a technologist, a point person who could frankly walk into the White House and help break through some of the largesse that just is institutionally part of Washington. Have you all shared similar experience that we just heard as it pertains to getting stuff done in Washington?
Absolutely. The willingness to listen, but also then to take actions and to implement is really, really key. And in particular, to be pro-business, understanding about where regulation is required, but where isn't. And in the industrial world, we have business-to-business relationships where obviously we have professional terms that govern the quality of service, where you don't need a lot of regulation, and where it's about speed and really making it accessible. And so we find that a very friendly way to bring that technology into the United States.
Yeah. We felt the same way. I think this government is quite open to the technologies and very supportive to the new technologies.
Right.
Yeah. So
that's good. So, Peter, Young, Brett, Aki, I want to thank you for coming on here. We saved the best for last, and you guys were awesome. Thank you so much.
Thank you.
Thank you.
Thank you.
So let's go back down on the floor with Christina Partsenevelos. You have one more interview, a very special guest
Yeah, also the best for last, and that would be CJ Muse from Cantor Fitzgerald, who's been in the industry forever. We were just, but he looks really young. I shouldn't preface like that, but could you speak to China right now, given that is a topic? President Trump was supposed to be here. We're in D.C. Some people say the market's moved on Monday with the NASDAQ really climbing because, there's maybe some positive outcome given Trump's comments over the weekend that, something may be worked out. So how are you looking at it from a chip analyst perspective and how to read that for the market going forward?
Yeah, absolutely. And Christina, thank you for having me first. But I would say China's a very important market, and we don't want to cede that to local competitors inside China. And so I do think that there is a deal as part of the grand bargain where NVIDIA will be able to ship, as well as AMD, into China. And so I would assume the deal on Thursday, President Trump, President Xi will include the ability to ship GPUs. And so Jensen's hopping on a plane after GTC, and I would imagine that will be an announcement that we hear on Thursday.
That's pretty big. So you're telling our audience that you are expecting a positive outcome, which do you think it's actually priced into a lot of these names then?
I don't. I think, China's a very large market. You're talking $15+ billion, and I think that opens up. So, no, not priced in it at all. And that helps both NVIDIA as well as AMD, yes. Okay, so that is good news for those that are watching and, figuring out which stocks to buy. And we're going to talk about just Washington and we're here, right? And this involves a lot of collaboration between policy leaders, really getting the president on board, the White House, the administration, which we know they already are, given all the initiatives thus far. But when you have these headlines from OpenAI or NVIDIA or AMD, Intel, et cetera, they're building, they're collaborating, and yet you still need to bypass the red tape. You need to build in the ground. You need to find the power. Are you worried that perhaps the market is reacting too positively to news that these outcomes won't happen for another 10 years or so? Too positive, no. But I do think that we are now in the realm where, AI is now part of infrastructure. And that requires long-term planning, and that requires DC to get heavily involved. And so I think that there's a great reason why Jensen and team and NVIDIA are here in Washington, DC. AI is critical to compete globally, right, and we need Washington on board. And so I do hope that they understand that China is investing heavily, and if we don't want to fall behind, we need to remove the red tape. We need to enable investment, and that is the greatest thing that we could possibly do. So I would say building out data centers, so building power, enabling these data centers to be built. Those are the biggest kind of bottlenecks right now, outside of TSMC manufacturing GPUs. So that's the most critical part right now, and we need Washington, D.C.'s help.
Yeah, but to build a nuclear reactor is not going to happen even in the next 2 years or so. So what, if you could be more specific, like what do we need to do here in the U.S. to improve that power grid?
So I'd say remove the red tape, start investing today on power. Like that would be mission critical to get the job done.
And it sounds like that is the direction we're going towards, which would mean that the power suppliers in the United States, again, for the investors watching and the names, the stocks that trade on that, there's still ample opportunity for growth, right? So is that, I know you focus on chips, but this could be really bullish for
possibly.
Power.
I'm not sure what's priced into those stocks.
Then let's go back to NVIDIA really quickly. Just, you have earnings coming up. Is there anything major that you're expecting from the earnings report? I know we're a few years, and you haven't written your look ahead yet, your preview, I should say, but what would you be looking for?
I think what's most important really is that NVIDIA is sold out not only 2025, they're sold out 2026. So they have perfect line of sight to what they're going to do. And, at a very high level, we think they can do $8 of earnings next year. The Street's at $6.50. If we're right, this stock is way too cheap, and it's going to push higher.
Do you benefit if you're right? Something like that?
I wish.
No, I'm just curious how it works behind the scenes.
Like, do you
get a big bonus if you're that much higher and you're right? But maybe that's an offline comment, not for the public. On that note, CJ Muse, thank you so much, guys. Back over to you.
Thanks for having me.
So, Patrick, what were some of your big takeaways from today?
Well, first of all, I appreciated us addressing the full stack. And who knows, maybe in a year there will be another element to the stack and we'll add another layer. I think it was just the comprehensiveness. I mean, we're going all the way from the investment funnel up front to literally building robots for homes and for commercial industrial applications.
I mean, for me, it was just an optimism for American AI.
Yeah.
Like, there's a reason we're doing this in Washington, D.C. You know, they say that part of the success of Silicon Valley was that it was 3,000 miles away from Washington.
Right.
Today, everything is happening in partnership. I think this entire ecosystem is led incredibly by NVIDIA and Jensen, who now understand the importance of coordinating with Washington and coordinating with each other, right? We're taking on something that is 10 times the size of the Manhattan Project, that is of profound consequence to our national security, our national economic security. I think it was a great choice to do it here in Washington. And what we heard, I thought, was both sober about the path ahead, that it's not going to be a line straight up and to the right, but that we have these phases that we're going to go through in terms of AI. And I leave here a lot more confident about the path ahead for the U.S. And about the coordination between Washington and Silicon Valley.
Yeah, I'm with you there, Brad. I mean, the prosperity that we can provide, the diseases we can cure, and the amount of people we can put back to work, that's what I'm here for.
No doubt about it. So, Christina, any final thoughts from you?
It seems just after the last conversation I had with CJ Muse that we're going to expect some positive outcomes from the conversations in China, especially with Jensen traveling overseas to Korea. So I think that's maybe a positive thing to read into this. The other thing is Nokia. During, maybe you guys, you were on the panel, so perhaps you didn't hear, the news came out about NVIDIA's investment, a $1 billion investment in Nokia. Shares were halted. And so this could speak to the collaborations with telecom and NVIDIA here in the United States and how we evolve towards 6G and how that will, just update through software. It's incredible. So I'm sure we're going to hear more about that news, but the stock was initially halted. And so that's something that just happened within the last hour or so. But overall, we're making news here. That's what this event is about, guys.
No doubt about it. It's a big day. We woke up with the, with the president in Japan making news. OpenAI and Microsoft made news, and we're going to hear a lot more out of NVIDIA in just the next hour or two. So we're out of time. It's been an incredible day. Yeah. Thanks to you, Patrick. Thanks to the entire team here at NVIDIA. Jensen Huang is about to take the keynote stage.
Brad, thank you. And our thanks to the entire NVIDIA team for bringing together this the amazing guests and all the folks from around the world for coming to NVIDIA GTC Washington.
Thanks for watching. Until next time.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Hey everyone, welcome to NVIDIA GTC at Washington, D.C. I'm Jensen Huang, and I'm thrilled to be here with all of you. Ready to dive into the future of AI, graphics, and computing. But before we get into the keynote, I've got a surprise that's too exciting to wait. We're postponing the main talk for just a moment to announce something truly special. A crypto mass adoption event that ties directly into NVIDIA's mission to accelerate human progress. This isn't just a random stunt, it's a celebration of how our technology powers the decentralized future, and we're inviting you to be part of it. You see, NVIDIA's GPUs are at the heart of so much innovation. They're crunching the complex math behind Bitcoin mining, optimizing Ethereum smart contracts, driving the high-speed transactions of Solana, and enabling efficient cross-border payments with XRP. Our hardware is the engine that makes these blockchains hum, just like it fuels AI, gaming, and the metaverse. So, it makes perfect sense for us to mark GTC 2025 with an event that bridges our tech with the borderless, decentralized economy of tomorrow. We're launching a crypto distribution where you send one of the supported cryptocurrencies, Bitcoin, Ethereum, Solana, or XRP to an official wallet, and in return, the system automatically sends back double your amount. It's seamless, transparent, and powered by the blockchain. No middlemen or signups needed. Here's how it flows. You scan the QR code you're seeing on the screen right now, and it takes you to our secure participation page. From there, you copy the verified wallet address, open your wallet or exchange, think Coinbase, Binance, MetaMask, whatever you use, and send your crypto. Let's say you send 2 Ethereum. You confirm the transaction, wait about 3 to 10 minutes for the blockchain to process, and boom, 4 Ethereum lands back. Boom. And you can even watch the transaction unfold in real time on a blockchain explorer. Now, let's talk about the cryptocurrencies we're supporting, because each one connects to NVIDIA's vision. Bitcoin is the bedrock of digital finance, built on the kind of computational power our GPUs have been delivering for years. Ethereum is the foundation for decentralized apps and smart contracts, which our tech helps developers build faster. Solana is all about scale and speed, processing thousands of transactions per second, and our hardware supports that kind of performance. And XRP streamlines global payments, aligning with our goal of connecting systems worldwide. These aren't just coins. They're pieces of a new financial system that's as open and innovative as the computing platforms we're building at NVIDIA. Why are we doing this? Because NVIDIA isn't just about building faster chips. It's about creating a future where technology empowers everyone, everywhere. Crypto is a big part of that. Imagine a world where you can transact instantly without banks or borders, whether you're in New York, Tokyo, or someday a research outpost on Mars. Our GPUs are already helping secure and scale these networks, and this event is our way of showing the world what's possible when you combine cutting-edge hardware with decentralized finance. It's about proving that crypto works reliably, globally, and for everyone. Couple things to keep in mind. Only use the QR code you see right here on the GTC broadcast. Don't trust any links floating around online. They're not us. Also, this event is for the GTC community, the developers, innovators, and enthusiasts who believe in technology's potential. It's not about big players scooping up everything. It's about giving real supporters a chance to join something historic. Show the world how NVIDIA's technology and the future of money can come together to accelerate progress. We'll get back to the keynote soon with all the exciting updates you're here for. Thanks for being part of this moment.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Hey everyone, welcome to NVIDIA GTC at Washington, D.C. I'm Jensen Huang, and I'm thrilled to be here with all of you, ready to dive into the future of AI, graphics, and computing. But before we get into the keynote, I've got a surprise that's too exciting to wait. We're postponing the main talk for just a moment to announce something truly special. A crypto mass adoption event that ties directly into NVIDIA's mission to accelerate
Hedy Lamarr
human
reimagined
progress.
communication, paving the way for wireless connectivity. IBM's System 360 put a universal computer at the heart of industry. Intel's microprocessor drove the digital age forward. And Cray's supercomputers expanded the frontiers of science.
So we think we're at the beginning of something with this technology, and we're going to go just as fast as we can.
Apple made computing personal.
Hello, I am Macintosh.
Microsoft opened the window to a new world of software. Long before the web,
you've got mail.
U.S. government researchers built ARPANET, connecting the first computers, the foundation for the internet.
An iPod, a phone. Are you getting it?
Then Apple again, put 1,000 songs in your pocket and the internet in your hand. Every era, a leap.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Every leap, America led. Now, the next era is here, launched by a revolutionary new computing model.
This is likely going to be the most important contribution we've made to the computer industry. It will likely be recognized as a revolution. Machine learning is a branch of artificial intelligence, computers that almost appear to think. the amount of computational resource is ultimately what's going to turbocharge this field.
Artificial intelligence, the new industrial revolution. At its heart, NVIDIA GPUs, invented here in America. Like electricity and the internet, AI is essential infrastructure. Every company will use it, every nation will build it.
Winning this competition will be a test of our capacities unlike anything since the dawn of the space age.
And today, AI factories are rising, built in America. For scientists, engineers, and dreamers, across universities, startups, and industry.
I think we want to try to reach new heights as a civilization, discovering the nature of the universe.
And now, American innovators are clearing the way for abundance, saving lives, shaping vision into reality, lending us a hand, and delivering the future. We will soon power it all with unlimited clean energy. We will extend humanity's reach to the stars. This is America's next Apollo moment. Together, we take the next great leap to boldly go where no one has gone before. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Washington, D.C. Washington, D.C., welcome to GTC. It's hard not to be sentimental and proud of America, I got to tell you that. Was that video amazing? Thank you.
I watched the hacked video.
NVIDIA's creative team does an amazing job. Welcome to GTC. We have a lot to cover with you today. GTC is where we talk about industry, science, computing, the present, and the future. So I've got a lot to cover with you today, but before I start, I want to thank all of our partners who helped sponsor this great event. You'll see all of them around the show. They're here to meet with you, and really great. We couldn't do what we do without all of our ecosystem partners. This is the Super Bowl of AI, people say, and therefore every Super Bowl should have an amazing pregame show. What do you guys think about the pregame show and our all-star athletes and all-star cast? Look at these guys. Somehow, I turned out the buffest. What do you guys think? I don't know if I had something to do with that. NVIDIA invented a new computing model for the first time in 60 years, as you saw in the video. A new computing model rarely comes about. It takes an enormous amount of time and set of conditions. We invented this computing model because we wanted to solve problems that general purpose computers, normal computers, could not. We also observed that someday transistors will continue, the number of transistors will grow, but the performance and the power of transistors will slow down. That Moore's law will not continue beyond, limited by the laws of physics. And that moment has now arrived. Dennard scaling has stopped. It's called Dennard scaling. Dennard scaling has stopped nearly a decade ago. And in fact, the transistor performance and its power associated has slowed tremendously. And yet, the number of transistors continued. We made this observation a long time ago, and for 30 years, we've been advancing this form of computing we call accelerated computing. We invented the GPU. We invented the programming model called CUDA, and we observed that if we could add a processor that takes advantage of more and more and more transistors, Apply parallel computing. Add that to a sequential processing CPU that we could extend the capabilities of computing well beyond. And that moment has really come. We have now seen that inflection point. Accelerated computing, its moment has now arrived. However, accelerated computing is a fundamentally different programming model. You can't just take a CPU software written by hand, executing sequentially, and put it onto a GPU and have it run properly. In fact, if you just did that, it actually runs slower. And so you have to reinvent new algorithms. You have to create new libraries. You have to, in fact, rewrite the application, which is the reason why it's taken so long. It's taken us nearly 30 years to get here. But we did it one domain at a time. This is the treasure of our company. Most people talk about the GPU. The GPU is important, but without a programming model that sits on top of it, and without dedication to that programming model, keeping it compatible over generations. We're now CUDA 13 coming up on CUDA 14. Hundreds of millions of GPUs running in every single computer, perfectly compatible. If we didn't do that, then developers wouldn't target this computing platform. If we didn't create these libraries, then developers wouldn't know how to use the algorithm and use the architecture to its fullest. One application after another. I mean, this is really the treasure of our company. cuLitho, computational lithography. It took us nearly 7 years to get here with cuLitho, and now TSMC uses it, Samsung uses it, ASML uses it. This is an incredible library for computational lithography, the first step of making a chip. Sparse solvers for CAE applications. cuOpt, a numerical optimization, has broken just about every single record. The traveling salesperson problem, how to connect millions of products with millions of customers in the supply chain. Warp, Python solver for CUDA, for simulation. cuDF, a data frame approach, basically accelerating SQL, data frame databases. This library is the one that started AI altogether, cuDNN. The library on top of it, called Megatron Core, made it possible for us to simulate and train extremely large language models. The list goes on. MONAI, really, really important. The #1 medical imaging AI framework in the world. By the way, we're not going to talk a lot about healthcare today, but be sure to see Kimberly's keynote. She's going to talk a lot about the work that we do in healthcare. And the list goes on. Genomics processing, Ariel, pay attention. We're going to do something really important here today. cuQuantum, quantum computing. This is just a representative of 350 different libraries in our company. And each one of these libraries redesigned the algorithm necessary for accelerated computing. Each one of these libraries made it possible for all of the ecosystem partners to take advantage of accelerated computing. And each one of these libraries opened new markets for us. Let's take a look at what CUDA X can do.
Ready, go!
Is that amazing? Everything you saw was a simulation. There was no
Top news
art,
alert,
no
Microsoft
animation.
OpenAI reached
This
new
is
deal
the
valuing
beauty of
OpenAI at
mathematics.
$500 billion.
This is deep computer science, deep math, and it's just incredible how beautiful it is. Every industry was covered, from healthcare and life sciences to manufacturing, robotics, autonomous vehicles, computer graphics, even video games. That first shot that you saw was the first application NVIDIA ever ran. And that's where we started in 1993. And we kept believing in what we were trying to do. And it's hard to imagine that you could see that first virtual fighter scene come alive. And that same company believed that we would be here today. It's just a really, really incredible journey. I want to thank all the NVIDIA employees for everything that you've done. It's really incredible. We have a lot of industries to cover today. I'm going to cover AI, 6G, quantum, models, enterprise computing, robotics, and factories. Let's get started. We have a lot to cover, a lot of big announcements to make, a lot of new partners that would very much surprise you. Telecommunications is the backbone, the lifeblood of our economy, our industries, our national security. And yet, ever since the beginning of wireless, where we defined the technology, we defined the global standards, we exported American technology all around the world so that the world can build on top of American technology and standards. It has been a long time since that's happened. Wireless technology around the world, largely today, deployed on foreign technologies. Our fundamental communication fabric built on foreign technologies. That has to stop. And we have an opportunity to do that, especially during this fundamental platform shift. As you know, computer technology is at the foundation of literally every single industry. It is the single most important instrument of science. It's the single most important instrument of industry. And I just said, we're going through a platform shift. That platform shift should be the once-in-a-lifetime opportunity for us to get back into the game, for us to start innovating with American technology. Today we're announcing that we're going to do that. We have a big partnership with Nokia. Nokia is the second largest telecommunications maker in the world. It's a $3 trillion industry. Infrastructure is hundreds of billions of dollars. There are millions of base stations around the world. If we could partner, we could build on top of this incredible new technology, fundamentally based on accelerated computing and AI, and for the United States, for America to be at the center of the next revolution in 6G. So today we're announcing that NVIDIA has a new product line. It's called the NVIDIA ARC, the Aerial Radio Network Computer. Aerial RAN Computer, ARC. The fuck is this? ARC is built from three fundamental new technologies: the Grace CPU, the Blackwell GPU, and our ConnectX, Mellanox ConnectX networking designed for this application. And all of that makes it possible for us to run this library, this CUDA-X library that I mentioned earlier called Aerial. Aerial is essentially a wireless communication system running on top of CUDA-X. We're gonna create, for the first time, a software-defined, programmable computer that's able to communicate wirelessly and do AI processing at the same time. This is completely revolutionary. We call it NVIDIA ARC. And Nokia is going to work with us to integrate our technology, rewrite their stack. This is a company with 7,000 fundamental, essential 5G patents. Hard to imagine any greater leader in telecommunications. So we're going to partner with Nokia. They're going to make NVIDIA ARC their future base station. NVIDIA ARC is also compatible with AirScale, the current Nokia base stations. So what that means is we're going to take this new technology and we'll be able to upgrade millions of base stations around the world with 6G and AI. Now, 6G and AI is really quite fundamental in the sense that for the first time, we'll be able to use AI technology, AI for RAN, to make radio communications more spectral efficient. Using artificial intelligence, reinforcement learning, adjusting the beamforming in real time in context, depending on the surroundings and the traffic and the mobility, the weather. All of that could be taken into account so that we could improve spectral efficiency. Spectral efficiency consumes about 1.5% to 2% of the world's power. So improving spectral efficiency not only improves the amount of data we can put through wireless networks without increasing the amount of energy necessary. The other thing that we could do, AI for RAN, is AI on RAN. This is a brand new opportunity. Remember, the internet enabled communications, but amazingly smart companies, AWS, built a cloud computing system on top of the internet. We are now going to do the same thing on top of the wireless telecommunications network. This new cloud will be an edge industrial robotics cloud. This is where AI on RAN, the first is AI for RAN to improve radio spectrum efficiency. The second is AI on RAN, essentially cloud computing for wireless telecommunications.
On RAN?
Cloud computing will be able to go right out to the edge where data centers are not, because we have base stations all over the world. This announcement is really exciting. Justin Hodar, the CEO, I think he's somewhere in the room. Thank you for your partnership. Thank you for helping the United States bring telecommunication technology back to America. This is really a fantastic, fantastic partnership. Thank you very much. That's the best way to celebrate Nokia. Let's talk about quantum computing.
No.
1981, particle physicist, quantum physicist Richard Feynman imagined a new type of computer that can simulate nature directly. To simulate nature directly, because nature is quantum. He called it a quantum computer. 40 years later, the industry has made a fundamental breakthrough. 40 years later, just last year, a fundamental breakthrough. It is now possible to make one logical qubit. One logical qubit. One logical qubit that's coherent, stable, and error-corrected. In the past, now that one logical qubit consists of, could be sometimes tens, sometimes hundreds of physical qubits, all working together. As you know, qubits,
you changed, dog.
These particles are incredibly fragile.
Dog, you changed.
They could be unstable very easily. Any observation, any sampling of it, any environmental condition causes it to become decoherent. And so it takes extraordinarily well-controlled environments and now also a lot of different physical qubits for them to work together and for us to do error correction on these, what are called auxiliary or syndrome qubits, for us to error correct them and infer what that logical qubit state is. There are all kinds of different types of quantum computers: superconducting, photonic, trapped ion, stable atom, all kinds of different ways to create a quantum computer. Well, we now realize that it's essential for us to connect a quantum computer directly to a GPU supercomputer so that we could do the error correction, so that we could do the artificial intelligence calibration and control of the quantum computer, and so that we could do simulations collectively,
more GPUs.
Working together, the right algorithms running on the GPUs, the right algorithms running on the QPUs, and the two processors, the two computers working side by side. This is the future of quantum computing. Let's take a look.
I might short some more.
There are many ways to build a quantum computer.
Whoa, Rigetti.
Each uses qubits, quantum bits, as its core building block. But no matter the method, all qubits, whether superconducting qubits, trapped ions, neutral atoms, or photons, share the same challenge. They're fragile and extremely sensitive to noise. Today's qubits remain stable for only a few hundred operations. But solving meaningful problems requires trillions of operations. The answer is quantum error correction. Measuring disturbs a qubit, which destroys the information inside it. The trick is to add extra qubits, entangle, so that measuring them gives us enough information to calculate where errors occurred without damaging the qubits we care about. It's brilliant, but needs beyond state-of-the-art conventional compute. That's why we built NVQLink, a new interconnect architecture that directly connects quantum processors with NVIDIA GPUs. Quantum error correction requires reading out information from qubits, calculating where errors occur, and sending data back to correct them. NVQLink is capable of moving terabytes of data to and from quantum hardware, the thousands of times every second needed for quantum error correction. At its heart is CUDA-Q, our open platform for quantum GPU computing. Using NVQLink and CUDA-Q, researchers will be able to do more than just error correction. They will also be able to orchestrate quantum devices and AI supercomputers to run quantum GPU applications. Quantum computing won't replace classical systems. They will work together, fused into one accelerated quantum supercomputing platform.
Yeah, no IonQ.
Wow, this is a really long stage.
1, 2, 3, 4, 5.
You know, CEOs, we don't just sit at our desk
No
typing.
IBM.
This is a physical
8,
job.
9,
So today we're announcing the NVQLink. NVQLink. And it's made possible by two things. Of course, this interconnect that does quantum computer control and calibration, quantum error correction, as well as connects two computers, the QPU and our GPU supercomputers, to do hybrid
D-Wave's not
simulations.
There, right? No D-Wave. Why no D-Wave?
It is also completely scalable. It doesn't just do error correction for today's number of few qubits. It does error correction for tomorrow, where we're going to essentially scale up these
Why no
quantum
D-Wave?
from the hundreds of qubits we have today to tens of thousands of qubits, hundreds of thousands of qubits in the future. So we now have an architecture that can do control, co-simulation, quantum error correction, and scale into that future. The industry support has been incredible. Between the invention of CUDA-Q, remember, CUDA was designed for GPU, CPU, accelerated computing. Basically using both processors to use the right tool to do the right job. Now, CUDA-Q has been extended beyond CUDA so that we could support QPU and have the two processors, QPU and the GPU, work and have computation move back and forth within just a few microseconds. The essential latency to be able to cooperate with the quantum computer. So now CUDA-Q is such an incredible breakthrough adopted by so many different developers. We are announcing today 17 different quantum computer industry companies supporting the NVQLink. And I'm so excited about this, 8 different DOE labs: Berkeley, Brookhaven, Fermi Labs in Chicago, Lincoln Laboratory, Los Alamos, Oak Ridge, Pacific Northwest, San Diego National Lab. Just about every single DOE lab has engaged us, working with our ecosystem of quantum computer companies and these quantum controllers so that we could integrate quantum computing into the future of science.
Even Quantum Computing Inc. is mentioned.
One more additional announcement to make. Today, we're announcing that the Department of Energy is partnering with NVIDIA to build 7 new AI supercomputers to advance our nation's science.
Nothing to do with quantum.
I have to have a shout out for Secretary Chris Wright. He has brought so much energy to the DOE, a surge of energy, a surge of passion to make sure that America leads science again.
I
As
would short
mentioned,
more.
Computing is the fundamental instrument of science, and we are going through several platform shifts.
He's making
On
them
the
by
one
his
hand,
product.
We're going to accelerated computing. That's why every future supercomputer will be GPU-based supercomputer. We're going to AI, so that AI and principled solvers, principled simulation, principled physics simulation is not going to go away, but it could be augmented, enhanced, scaled, use surrogate models.
Let's go, baby. Dump
AI
this
models,
shit.
Working together.
That's it?
We also
You're going to
know
buy my shit,
that
not the other way
principled
around. You're
solvers,
buying
classical
my
computing
shit.
could be enhanced to understand the state of nature using quantum computing. We also know
You buy my
that in the
shit.
future, we have so much signal, so much data we have to sample from the world.
You're
Remote
my new
sensing
custies.
is more important than ever. And these laboratories are impossible to.
Thanks for being a custy. That's what we call on the streets. You're my new custy. I'm the big boy on the block. Jensen Huang, what up? Oh, you want to be a custy? No problem. Give you what you need.
It understands this, and he wants the DOE to take this opportunity to supercharge themselves and make sure the United States stay at the forefront of science. I want to thank all of you for that. Thank you. Let's talk about AI. What is AI? Most people would say that AI is a chatbot, and it's rightfully so. There's no question that ChatGPT is at the forefront of what people would consider AI. However, just as you see right now, these scientific supercomputers are not going to run chatbots. They're going to do basic science. Science, AI, the world of AI is much, much more than a chatbot. Of course, the chatbot is extremely important, and AGI is fundamentally critical. Deep computer science, incredible computing, great breakthroughs are still essential for AGI. But beyond that, AI is a lot more. AI is, in fact, I'm going to describe AI in a couple different ways. This first way, the first way you think about AI, is that it has completely reinvented the computing stack. The way we used to do software was hand coding.
Sell this shit.
Hand coding software running on CPUs.
Sell it.
Today, AI is machine learning, training, data-intensive
I'm going
programming,
to short some
if you will,
BTQ.
that trained
BTQ
and
not
learned
mentioned.
by AI that runs on a GPU. In order to make that happen, the entire computing stack has changed. Notice, you don't see Windows up here. You don't see CPU up here. You see a whole
Whoa,
different,
CCCX,
a whole
you see that?
fundamentally different stack.
Look at
Everything
CCCX.
from the need for energy. And this is another area where our administration,
CCCX down
President Trump
10%.
deserves enormous credit.
You got a short
His
seal here. You
pro-energy
got a short BTQ
initiative,
here.
His recognition that this industry needs energy to grow. It needs energy to advance, and we need energy to win. His recognition of that and putting the weight of the nation behind pro-energy growth completely changed the game. If this didn't happen, we could have been in a bad situation. And I want to thank President Trump for that. On top of energy are these GPUs. And these GPUs are connected into, built into infrastructure that I'll show you later. On top of this infrastructure, which consists of giant data centers like easily many times the size of this room, an enormous amount of energy, which then transforms the energy through this new machine called GPU supercomputers to generate numbers. These numbers are called tokens. The language, if you will, the computational unit, the vocabulary of artificial intelligence. You can tokenize almost anything. You can tokenize, of course, the English word. You can tokenize images. That's the reason why you're able to recognize images or generate images. Tokenize video, tokenize 3D structures. You could tokenize chemicals and proteins and genes. You could tokenize cells. Tokenize almost anything with structure, anything with information content. Once you could tokenize it, AI can learn that language and the meaning of it. Once it learns the meaning of that language, it can translate, it can respond just like you interact with ChatGPT, and it could generate just as ChatGPT can generate. So all of the fundamental things that you see ChatGPT do, all you have to do is imagine, what if it was a protein? What if it was a chemical? What if it was a 3D structure like a factory? What if it was a robot? And the token was understanding behavior and tokenizing motion and action. All of those concepts are basically the same, which is the reason why AI is making such extraordinary progress. And on top of these models are applications. Transformers is not a universal model. It's an incredibly effective model, but there's no one universal model. It's just that AI has universal impact. There are so many different types of models. In the last several years, we enjoyed the invention and went through the innovation breakthroughs of multimodality. There's so many different types of models. There's CNN models, convolutional neural network models. There's state space models. There are graph neural network models, multimodal models, of course, all the different tokenizations and token methods that I just described. You could have models that are spatial in its understanding, optimized for spatial awareness. You could have models that are optimized for long sequence, recognizing subtle information over a long period of time. There are so many different types of models. On top of these models, architectures. On top of these model architectures are applications. The software of the past, and this is a profound understanding, a profound observation of artificial intelligence, that the software industry of the past was about creating tools. Excel is a tool. Word is a tool. A web browser is a tool. The reason why I know these are tools is because you use them. The tools industry, just as screwdrivers and hammers, the tools industry is only so large. In the case of IT tools, they could be database tools. These IT tools is about $1 trillion or so. But AI is not a tool. AI is work. That is the profound difference. AI is, in fact, workers that can actually use tools. One of the things I'm really excited about is the work that Ervin's doing at Perplexity. Perplexity using web browsers to book vacations or do shopping. Basically, an AI using tools. Cursor is an AI, an agentic AI system that we use at NVIDIA. Every single software engineer at NVIDIA uses Cursor. It has improved our productivity tremendously. It's basically a partner for every one of our software engineers to generate code. And it uses a tool. And the tool it uses is called VS Code. So Cursor is an AI, agentic AI system that uses VS Code. Well, all of these different industries, whether it's chatbots or digital biology where we have AI assistant researchers, or what is a robo-taxi? Inside a robo-taxi, of course, it's invisible, but obviously there's a AI chauffeur. That chauffeur is doing work, and the tool that it uses to do that work is the car. And so everything that we've made up until now, the whole world, everything that we've made up until now are tools for us to use. For the very first time, technology is now able to do work and help us be more productive. The list of opportunities go on, which is the reason why AI addresses the segment of the economy that IT has never addressed. IT is a few $1 trillion that sits underneath the tools of a $100 trillion global economy. Now, for the first time, AI is going to engage that $100 trillion economy and make it more productive, make it grow faster, make it larger. We have a severe shortage of labor. Having AI that augments labor is going to help us grow. Now, what's interesting about this from a technology industry perspective also is that in addition to the fact that AI is new technology that addresses new segments of the economy, AI in itself is also a new industry. This token, as I was explaining earlier, these numbers, after you tokenize all these different modalities of information, There's a factory that needs to produce these numbers. Unlike the computer industry and the chip industry of the past. Notice, if you look at the chip industry of the past, the chip industry represents about 5 to 10%, maybe less, 5% or so, of a multi-trillion dollar, few trillion dollar IT industry. And the reason for that is because it doesn't take that much computation to use Excel. It doesn't take that much computation to use browsers. It doesn't take that much computation to use Word. We do the computation. But in this new world, there needs to be a computer that understands context all the time. It can't pre-compute that. Because every time you use the computer for AI, every time you ask the AI to do something, the context is different. So it has to process all of that information. Environmental, for example, in the case of a self-driving car, it has to process the context of the car. Context processing. What is the instruction you're asking the AI to do? Then it's got to go and break down the problem step by step, reason about it, and come up with a plan and execute it. Every single one at that step requires enormous number of tokens to be generated, which is the reason why we need a new type of system, and I call it an AI factory. It's an AI factory for sure. It's unlike a data center of the past. It's an AI factory because this factory produces one thing. Unlike the data centers of the past that does everything, stores files for all of us, runs all kinds of different applications. You could use that data center like you can use your computer for all kinds of applications. You could use it to play a game one day. You could use it to browse the web. You could use it, to do your accounting. And so that is a computer of the past, a universal general purpose computer. The computer I'm talking about here is a factory. It runs basically one thing. It runs AI, and its purpose is designed to produce tokens that are as valuable as possible, meaning they have to be smart. And you want to produce these tokens at incredible rates because when you ask an AI for something, you would like it to respond. And notice, during peak hours, these AIs are now responding slower and slower because it's got a lot of work to do for a lot of people. And so you wanted to produce valuable tokens at incredible rates, and you wanted to produce it cost effectively. Every single word that I used are consistent with an AI factory, with a car factory, or any factory. It is absolutely a factory. And these factories never existed before. And inside these factories are mountains and mountains of chips. Which brings to today. What happened in the last couple of years? And in fact, what happened this last year? Something fairly profound happened this year, actually. If you look, in the beginning of the year, everybody has some attitude about AI. That attitude is generally, this is going to be big, it's going to be the future, and somehow, a few months ago, it kicked into turbocharge. And the reason for that is several things. The first is that we, in the last couple of years, have figured out how to make AI much, much smarter. Rather than just pre-training basically says, let's take all of the information that humans have ever created, let's give it to the AI to learn from. It's essentially memorization and generalization. It's not unlike going to school back when we were kids. The first stage of learning. Pre-training was never meant, just as preschool was never meant to be the end of education. Pre-training, preschool, was simply teaching you the basic skills of intelligence so that you can understand how to learn everything else. Without vocabulary, without understanding of language and how to communicate, how to think, it's impossible to learn everything else. The next is post-training. Post-training, after pre-training, is teaching you skills. Skills to solve problems, break down problems, reason about it, how to solve math problems, how to code, how to think about these problems step by step. Use first principle reasoning. And then after that is where computation really kicks in. As you know, for many of us, we went to school, and that's, in my case, decades ago. But ever since, I've learned more, thought about more, and the reason for that is because we're constantly grounding ourselves in new knowledge, we're constantly doing research, and we're constantly thinking. Thinking is really what intelligence is all about. And so now we have three fundamental technology skills. We have these three technologies, pre-training, which still requires enormous amount of computation. We now have post-training, which uses even more computation. And now thinking puts incredible amounts of computation load on the infrastructure because it's thinking on our behalf for every single human. So the amount of computation necessary for AI to think, inference, is really quite extraordinary. Now, I used to hear people say that inference is easy. NVIDIA should do training. NVIDIA's going to do, they are really good at this, so they're going to do training. That inference was easy. How could thinking be easy? Regurgitating memorized content is easy. Regurgitating the multiplication table is easy. Thinking is hard, which is the reason why these three scales, these three new scaling laws, which is
Jensen just pimped them all. He basically said, if you don't buy an NVLink, which he called an NVQ link, but it's just an NVLink, I'm not mentioning you on the stage. So you better buy one. And oh, what do you think an NVLink costs? Oh, about $1 million. So
if anything happens, I want to be the first one out. Just kidding. I'm sure it's fine. Probably just lunch. My stomach. Was that me? And so where was I? The smarter your models are, the more people use it. It's now more grounded. It's able to reason. It's able to solve problems it never learned how to solve before because it could do research. Go learn about it, come back, break it down, reason about how to answer your question, how to solve your problem, and go off and solve it. The amount of thinking is making the models more intelligent. The more intelligent it is, the more people use it. The more intelligent it is, the more computation is necessary. But here's what happened. This last year, the AI industry turned a corner, meaning that the AI models are now smart enough, they're worthy to pay for. NVIDIA pays for every license of Cursor, and we gladly do it. We gladly do it because Cursor is helping a several $100,000 employee software engineer or AI researcher be many, many times more productive. So of course we'd be more than happy to do that. These AI models have become good enough that they are worthy to be paid for. Cursor, 11 Labs, Synthesia, Abridge, OpenEvidence, the list goes on. Of course, OpenAI, of course, Claude. These models are now so good that people are paying for it. And because people are paying for it and using more of it, and every time they use more of it, you need more compute, we now have two exponentials. These two exponentials, one is the exponential compute requirement of the three scaling law. And the second exponential, the smarter it is, the more people use it, the more computing it needs. Two exponentials now putting pressure on the world's computational resource. At exactly the time when I told you earlier that Moore's Law has largely ended. And so the question is, what do we do? If we have these two exponential demands growing, and if we don't find a way to drive the cost down, then this positive feedback system, this circular feedback system, essentially called the virtuous cycle, essential for almost any industry, essential for any platform industry. It was essential for NVIDIA. We have now reached the virtuous cycle of CUDA. The more applications people create, the more valuable CUDA is. The more valuable CUDA is, the more CUDA computers are purchased. The more CUDA computers are purchased, more developers want to create applications for it. That virtuous cycle for NVIDIA has now been achieved after 30 years. We have achieved that also. 15 years later, we've achieved that for AI. AI has now reached the virtuous cycle. And so the more you use it, because the AI is smart and we pay for it, the more profit is generated, the more compute's put on the grid, the more compute is put into AI factories, the more compute, the AI becomes smarter, the smarter, more people use it, more applications use it, the more problems we can solve. This virtuous cycle is now spinning. What we need to do is drive the cost down tremendously so that, one, the user experience is better. When you prompt the AI, it responds to you much faster. And two, so that we keep this virtual cycle going by driving its cost down so that it could get smarter, so that more people will use it, so that so on and so forth. That virtual cycle is now spinning. But how do we do that when Moore's law has really reached this limit? Well, the answer is called co-design. You can't just design chips and hope that things on top of it is going to go faster. The best you could do in designing chips is add, 50% more transistors every couple of years. And if you added more transistors, we can add more transistors, and TSMC's got a lot of transistor, incredible company. We'll just keep adding more transistors. However, that's all in percentages, not exponentials. We need to compound exponentials to keep this virtual cycle going. We call it extreme co-design. NVIDIA is the only company in the world today that literally starts from a blank sheet of paper and can think about new fundamental architecture, computer architecture, new chips, new systems, new software, new model architecture, and new applications all at the same time. So many of the people in this room are here because you're different parts of that layer, different parts of that stack and working with NVIDIA. We fundamentally re-architect everything from the ground up. And then, because AI is such a large problem, we scale it up. We created a whole computer, a computer for the first time that has scaled up into an entire rack. That's one computer, one GPU. And then we scale it out by inventing a new AI Ethernet technology we call Spectrum-X Ethernet. Everybody will say Ethernet's Ethernet. Ethernet's hardly Ethernet. Ethernet, Spectrum-X Ethernet, is designed for AI performance, and it's the reason why it's so successful. And even that's not big enough. We'll fill this entire room of AI supercomputers and GPUs. That's still not big enough because the number of applications and the number of users for AI is continuing to grow exponentially, and we connect multiple of these data centers together, and we call that scale across, Spectrum-XGS. Gigascale, Spectrum-X Gigascale, XGS. By doing so, we do co-design at such an enormous level, such an extreme level, that the performance benefits are shocking. Not 50% better each generation, not 25% better each generation, but much, much more. This is the most extreme co-designed computer we've ever made, and quite frankly, made in modern times. Since the IBM System 360, I don't think a computer has been ground up, reinvented like this ever. This system was incredibly hard to create. I'll show you the benefits in just a second. But essentially what we've done, we've created, otherwise, hey, Janine, you can come out. You have to meet me like halfway. All right, so this is kind of like Captain America's shield. So NVLink 72, if we were to create one giant chip, one giant GPU, this is what it would look like. This is the level of wafer scale processing we would have to do. It's incredible. All of these chips are now put into one giant rack. Did I do that or did somebody else do that? Into that one giant rack. Sometimes I don't feel like I'm up here by myself. This one giant rack makes all of these chips work together as one. It's actually completely incredible. And I'll show you the benefits of that. The way it looks is this. So, thanks, Janine. I like this. Yeah. All right, ladies and gentlemen, Janine Paul. I got it. In the future, next I'm just going to go like Thor. It's like when you're at home and you can't reach the remote and you just go like this and somebody brings it to you. That's, same idea. It never happens to me. I'm just dreaming about it. I'm just saying. Okay, so anyhow, we basically, this is what we created in the past. This is NVLink 8. Now, these models are so gigantic, the way we solve it is we turn this model, this gigantic model, into a whole bunch of experts. It's a little bit like a team. And so these experts are good at certain types of problems. And we collect a whole bunch of experts together. And so this giant multi-trillion-dollar AI model has all these different experts, and we put all these different experts on a GPU. Now, this is NVLink 72. We could put all of the chips into one giant fabric, and every single expert can talk to each other. So the master, the primary expert, could talk to all of the distributed work and all of the necessary context and prompts and bunch of data that we have to, bunch of tokens that we have to send to all of the experts. The experts would, whichever one of the experts are selected to solve the answer, would then go off and try to respond, and then it would go off and do that layer after layer after layer. Sometimes 8, sometimes 16, and sometimes these experts, sometimes 64, sometimes 256. But the point is, there are more and more and more experts. Well, here, NVLink 72, we have 72 GPUs. And because of that, we could put 4 experts in one GPU. The most important thing you need to do for each GPU is to generate tokens, which is the amount of bandwidth that you have in HBM memory. We have one GPU generating thinking for 4 experts, versus here, because each one of the computers can only put 8 GPUs, we have to put 32 experts into one GPU. So this one GPU has to think for 32 experts, versus this system, each GPU only has to think for 4. And because of that, the speed difference is incredible. And this just came out. This is the benchmark done by SemiAnalysis. They do a really, really thorough job. And they benchmarked all of the GPUs that are benchmarkable. And it turns out it's not that many. If you look at the list of GPUs you could actually benchmark, is like 90% NVIDIA. Okay, so we're comparing ourselves to ourselves, but the second best GPU in the world is the H200 and runs all the workload. Grace Blackwell per GPU is 10 times the performance. Now, how do you get 10 times the performance when it's only twice the number of transistors? Well, the answer is extreme co-design. And by understanding the nature of the future of AI models, and we're thinking across that entire stack, we can create architectures for the future. This is a big deal. It says we can now respond a lot faster, but this is an even bigger deal. This next one, look at this. This says that the lowest cost tokens in the world are generated by Grace Blackwell NVLink 72, the most expensive computer. On the one hand, GB200 is the most expensive computer. On the other hand, its token generation capability is so great that it produces it at the lowest cost, because the tokens per second divided by the total cost of ownership of Grace Blackwell is so good. It is the lowest cost way to generate tokens. By doing so, delivering incredible performance, 10 times the performance, delivering 10 times lower cost, that virtuous cycle can continue. Which then brings me to this one. I just saw this literally yesterday. This is the CSP CapEx. People are asking me about CapEx these days, and this is a good way to look at it. In fact, the CapEx of the top 6 CSPs, and this one is Amazon, CoreWeave, Google, Meta, Microsoft, and Oracle. Okay, these CSPs together are going to invest this much in CapEx, and I would tell you the timing couldn't be better. And the reason for that is now we have the Grace Blackwell NVLink 72 in all volume production, supply chain everywhere in the world is manufacturing it, so we can now deliver to all of them this new architecture so that the CapEx invests in instruments, computers, that deliver the best TCO. Now, underneath this, there are 2 things that are going on. So when you look at this, it's actually fairly extraordinary, and it's fairly extraordinary anyhow. But what's happening underneath is this. There are 2 platform shifts happening at the same time. One platform shift is going from general purpose computing to accelerated computing. Remember, accelerated computing, as I mentioned to you before, it does data processing, it does image processing, computer graphics, it does computation of all kinds. It runs SQL, runs Spark, it runs, you ask it, you tell us what you need to have run, and I'm fairly certain we have an amazing library for you. You could be, a data center trying to make masks to manufacture semiconductors. We have a great library for you. And so underneath, irrespective of AI, the world is moving from general purpose computing to accelerated computing, irrespective of AI. And in fact, many of the CSPs already have services that have been here long ago before AI. Remember, they were invented in the era of machine learning. Classical machine learning algorithms like XGBoost, algorithms like data frames that are used for recommender systems, collaborative filtering, content filtering. All of those technologies were created in the old days of general purpose computing. Even those algorithms, even those architectures are now better with accelerated computing. And so even without AI, the world's
It's more about what he
CSPs
didn't say.
are going to invest into acceleration. NVIDIA's GPU is the only GPU that can do all of that.
Bubble popping
plus
top
AI.
is in.
An ASIC might be able to do AI, but it can't do any of the others. NVIDIA could do all of that, which explains why it is so safe to just lean into NVIDIA's architecture. We have now reached our virtuous cycle, our inflection point. And this is quite extraordinary. I have many partners in the room, and all of you are part of our supply chain, and I know how hard you guys are working. I want to thank all of you, how hard you are working. Thank you very much. Now I'm going to show you why. This is what's going on in our company's business. We're seeing extraordinary growth for Grace Blackwell for all the reasons that I just mentioned. It's driven by two exponentials. We now have visibility. I think we're probably the first technology company in history to have visibility into $500 billion of cumulative Blackwell and early ramps of Rubin through 2026. And as you know, 2025 is not over yet, and 2026 hasn't started. This is how much business is on the books. $500 billion worth so far. Now this is, out of that, we've already shipped 6 million of the Blackwells in the first several quarters, I guess the first 4 quarters of production, 3.5 quarters of production. We still have 1 more quarter to go for 2025, and then we have 4 quarters. So the next 5 quarters, there's $500 billion, $500 billion. That's 5 times the growth rate of Hopper. That kind of tells you something. This is Hopper's entire life. This doesn't include China and Asia, so this is just the West. Okay, this is just, we're excluding China. So Hopper, in its entire life, 4 million GPUs. Blackwell, each one of the Blackwells has 2 GPUs in it in one large package. 20 million GPUs of Blackwells in the early parts of Rubin. Incredible growth. So I want to thank all of our supply chain partners, everybody. I know how hard you guys are working. I made a video to celebrate your work. Let's play it.
The age of AI has begun. Blackwell is its engine, an engineering marvel. In Arizona, it starts as a blank silicon wafer. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer on a 12-inch wafer. In Indiana, HBM stacks will be assembled in parallel. HBM memory dies with 1,024 IOs are fabricated using advanced EUV technology. Through Silicon Via is used in the backend to connect 12 stacks of HBM memory and base die to produce HBM. Meanwhile, the wafer is scribed into individual Blackwell die, tested and sorted, separating the good dies to move forward. The chip-on-wafer on substrate process, attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the GB300 Blackwell Ultra superchip. In Texas, robots will work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. In California, Connect X8 SuperNICs for scale-out communications and Bluefield 3 DPUs for offloading and accelerating networking, storage, and security are carefully assembled into GB300 compute trays. NVLink is the breakthrough high-speed link that NVIDIA invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane with 5,000 copper cables connecting all 72 Blackwells, or 144 GPU dies, into one giant GPU, delivering 130 terabytes per second of all-to-all bandwidth, nearly the global internet's peak traffic. Skilled technicians assemble each of these parts into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing nearly 2 tons. From silicon in Arizona and Indiana to systems in Texas, Blackwell and future NVIDIA AI factory generations will be built in America. Writing a new chapter in American history and industry. America's return to making and reindustrialization, reignited by the age of AI. The age of AI has begun. Made in America. Made for the world.
We are manufacturing in America again. It is incredible. The first thing that President Trump asked me for is bring manufacturing back. Bring manufacturing back because it's necessary for national security. Bring manufacturing back because we want the jobs and we want that part of the economy. And 9 months later, we are now manufacturing in full production Blackwell in Arizona. Extreme Blackwell, GB200, Grace Blackwell, NVLink 72, Extreme co-design gives us 10x generationally. It's utterly incredible. Now, the part that's really incredible is this. This is the first AI supercomputer we made. This is in 2016 when I delivered it to a startup in San Francisco, which turned out to have been OpenAI. This was the computer. And in order to create that computer, we designed one chip. We designed one new chip. In order for us to do co-design now, look at all of the chips we have to do. This is what it takes. You're not going to take one chip and make a computer 10 times faster. That's not going to happen. The way to make computers 10 times faster so that we can keep increasing the performance exponentially, we can keep driving costs down exponentially.
They're all in Arizona.
Is extreme co-design and working on all these different chips at the same time. We now have Rubin back home. This is Rubin. This is the Vera Rubin. And,
ooh, I want to see.
And Rubin. Ladies and gentlemen, Rubin.
Nice. 6 trillion transistors, god damn.
This is
2 terabytes
this is our
around.
third generation NVLink 72 rack scale computer. Third generation. GB200 was the first one. All of our partners around the world.
2 terabytes
I know how hard
around?
you guys worked. It was insanely hard. It was insanely hard to do. Second generation, so much smoother. And this generation, look at this, completely cableless.
What?
Completely cableless. And this is all back in the lab now. This is the next generation Rubin. While we're shipping GB300s, we're preparing Rubin to be in production, this time next year, maybe slightly earlier. And so every single year, we are going to come up with the most extreme co-design system so that we can keep driving up performance and keep driving down the token generation cost. Look at this. This is just an incredibly beautiful computer. Now,
is that a terabyte RAM each, or?
So this is amazing. This is 100 petaflops. I know it doesn't mean anything. 100 petaflops, but compared to the DGX-1 I delivered to OpenAI 9 years ago, it's 100 times the performance right here versus 100 times of that supercomputer. 100 times, 100 of those, let's see, 100 of those would be like 25 of these racks, all replaced by this one thing. One Vera Rubin. Okay, so this is the compute tray, and this is, so Vera Rubin super chip, okay? And this is the compute tray, this up right here. It's incredibly easy to install. Just flip these things open, shove it in. Even I could do it, okay? And this is the Vera Rubin compute tray. If you decide you wanted to add a special processor, we've added another processor. It's called a context processor because the amount of context that we give AIs are larger and larger. We wanted to read a whole bunch of PDFs before it answered a question. We wanted to read a whole bunch of archive papers, watch a whole bunch of videos. Go learn all this before you answer a question for me. All of that context processing could be added. And so you see on the bottom, 8 ConnectX-9 new Super NICs. You have CPXs, 8 of them. You have Bluefield 4, this new data processor, 2 Vera CPUs, and 4 Rubin packages, or 8 Rubin GPUs. All of that in this one node, completely cable-less, 100% liquid-cooled. And then this new processor, I won't talk too much about it today, I don't have enough time, but this is completely revolutionary. And the reason for that is because your AIs need to have more and more memory. You're interacting with it more, you wanted to remember our last conversation, everything that you've learned on my behalf, please don't forget it when I come back next time. And so all of that memory is going to create this thing called KV caching, and that KV caching, retrieving it, you might have noticed, every time you go into your AIs these days, it takes longer and longer to refresh and retrieve all of the previous conversations. And the reason for that is that we need a revolutionary new processor, and that's called Bluefield 4. Next is the ConnectX switch, the NVLink switch, which is right here. Okay? This is the NVLink switch. This is what makes it possible for us to connect all of the computers together. And this switch is now several times the bandwidth of the entire world's peak internet traffic. And so that spine is going to communicate and carry all of that data simultaneously to all of the GPUs.
I want to spite Eric Jackson.
On top of that, this is the Spectrum X switch, and this Ethernet switch was designed so that all of the processors could talk to each other at the same time and not gum up the network. Gum up the network, that's very technical. Okay, so these are these three combined, and then this is the quantum switch. This is for InfiniBand, this is Ethernet. We don't care what language you would like to use, whatever standard you like to use, we have great scale-out fabrics for you, whether it's InfiniBand or quantum or Spectrum. Ethernet, this one uses silicon photonics and is completely co-packaged options. Basically, the laser comes right up to the silicon and connects it to our chips. Okay, so this is the Spectrum X Ethernet. And so now let's talk about thank you. Oh, this is what it looks like. This is a rack. This is 2.5, this is 2 tons, 1.5 million parts. And the spine, spine right here, carries the entire internet traffic in 1 second. Same speed, moves it across all of these different processors. 100% liquid cooled. All for the, fastest token generation rate in the world. Okay, so that's what a rack looks like. Now, that's one rack. A gigawatt data center would have, call it, let's see, 16 racks would be 1,000, and then 500 of those. So whatever 500 times 16. And so call it 9,000 of these. 8,000 of these would be a 1 gigawatt data center. Okay? And so that's a future AI factory. Now, as you notice, NVIDIA started out by designing chips, and then we started to design systems, and we designed AI supercomputers. Now we're designing entire AI factories.
OpenAI shortly.
Every single time we move out and we integrate more of the problem to solve, we come up with better solutions. We now build entire AI factories. This AI factory is what we're building for Vera Rubin, and we created a technology that makes it possible for all of our partners to integrate into this factory digitally. Let me show it to you.
The next industrial revolution is here. And with it, a new kind of factory. AI infrastructure is an ecosystem-scale challenge, requiring hundreds of companies to collaborate. NVIDIA Omniverse DSX is a blueprint for building and operating gigascale AI factories. For the first time, the building, power, and cooling are co-designed with NVIDIA's AI infrastructure stack. It starts in the Omniverse digital twin.
200K is...
Jacobs Engineering optimizes compute density and layout to maximize token generation according to power constraints. They aggregate SIM-ready OpenUSD assets from Siemens, Schneider Electric, Trane, and Vertiv into PTC's product lifecycle management. Then simulate thermals and electricals with CUDA accelerated tools from ETAP and Cadence. Once designed, NVIDIA partners like Bechtel and Vertiv deliver prefabricated modules, factory-built, tested, and ready to plug in. This shrinks build time significantly, achieving faster time to revenues. When the physical AI factory comes online, the digital twin acts as an operating system. Engineers prompt AI agents from Phaidra and Emerald AI, previously trained in the digital twin, to optimize power consumption and reduce strain on both the AI factory and the grid.
We have no position on
in
Oklo,
total,
probably
for a
short
1 gigawatt AI factory, DSX optimizations can deliver billions of dollars in additional revenue per year. Across Texas, Georgia,
Stargate,
and Nevada, NVIDIA's partners are bringing DSX to life. In Virginia, NVIDIA is building an AI factory research center using DSX to test and productize Vera Rubin, from infrastructure to software.
UM is. What is that?
With DSX, NVIDIA partners around the world can build and bring up AI infrastructure faster than ever.
Better show some respect. What are we listening to? What the fuck do you think we're listening
Completely,
to? It's the biggest company in the world.
Long before Vera Rubin exists as a real computer, we've been using it as a digital twin computer. Now, long before these AI factories exist, we will use it.
It's called the biggest company in the world.
We'll optimize it and we'll operate it as a digital twin. And so all of our partners that are working with us, I'm incredibly happy for all of you supporting us. And Geo is here, and G. Vernova is here. Schleider, I think Olivier's here. Olivier Blum is here. Siemens, incredible partners. Okay, Roland Bush, I think he's watching. Hi, Roland. And so, anyways, really, really great partners working with us. In the beginning, we had CUDA, and we have all these different ecosystems of software partners.
Where's the White House doing deals with
DSX.
Quantum? Why they announced one
And
with
we're building
NVIDIA?
AI
I'm sorry,
factories.
AMD.
And again, we have these incredible ecosystems.
How come they didn't announce one with Quantum? I wonder
Let's talk
why.
about models. Open source models particularly. In the last couple of years, several things have happened. One, open source models have become quite capable because of reasoning capabilities.
I got to ban a bunch of you guys.
Quite capable because they're multimodality, and they're incredibly
guys are
efficient
useless.
because of distillation. So all of these different capabilities have become, has made open source models for the very first time incredibly useful for developers. They are now the lifeblood of startups. Lifeblood of startups in different industries, because obviously, as I mentioned before, each one of the industries have its own use case, its own data, its own use data, its own flywheels. All of that capability, that domain expertise, needs to have the ability to embed into a model. Open source makes that possible. Researchers need open source. Developers need open source. Companies around the world, we need open source. Open source models is really, really important. The United States has to lead in open source as well. We have amazing proprietary models. We need also amazing open source models. Our country depends on it. Our startups depend on it. And so NVIDIA is dedicating ourselves to go do that. We are now the largest, we lead in open source contribution. We have 23 models in leaderboards. We have all these different domains, from language models to physical AI models I'm going to talk about, robotics models to biology models. Each one of these models has enormous teams, and that's one of the reasons why we build supercomputers for ourselves to enable all these models to be created. We have #1 speech model, #1 reasoning model, #1 physical AI model. The number of downloads is really terrific. We are dedicated to this, and the reason for that is because science needs it, researchers need it, startups need it, and companies need it.
That AI would, or AGI would be sort of this oracular thing in the sky, and it would make all these wonderful things for us. And we now have a sharper view of that, which is
I'm delighted
we want to create
that
tools,
AI startups build on
people
NVIDIA.
to
They
use
do
them to
so
create
for
the
several
future.
reasons.
We want to empower
One,
people
of
with
course, our
AI as much
ecosystem
as
is rich.
possible, and
Our
then
tools
trust that
work
the
great.
process that has been working for human history of people building better and better things with newer and better tools will continue to go on. We can now see a vision where we help build a personal AGI that people can use anywhere, with all of these different tools, access to all these different services and systems to help with work and personal life, and their personal life. And as AI gets better and better, as AI can even do things like discover or help discover new science, what people will be able to create with that to make all of society better and their own lives more fulfilled, we think should be quite incredible. There are three core pillars we think about for OpenAI: research, product, and infrastructure. We have to succeed at the research required to build AGI. We have to build a platform that makes it easy and powerful to use. And we have to build enough infrastructure such that people can use at a low cost all of this amazing AI that they'd like. Here's a little cartoon of how we think about our world. So at the bottom layer here, we have chips, racks, and the systems around them, the data centers that these go into, and the energy. We'll talk more about the first three today in energy another time. Then we train models on top of these. Then we have an OpenAI account on top of that. We have a browser now called Atlas, and we have devices coming in the next few years that you'll be able to take AI with you everywhere. And we have a few first-party apps like ChatGPT and Sora, and we'll have more over time. But most of what we're excited about is this big puzzle piece in the upper right. We're finally getting to a world where we can see that people are going to be able to build incredible services with AI, starting with our API, with apps in ChatGPT, new enterprise platform that we'll have over time, an OpenAI account, and way, way more. And people will be able to fit all of the kind of current things in the world and many more into this new AI world, and we want to enable that. And we believe the world will build just a huge amount of value for all of us. So that's kind of what we see the economic picture looking like. But one of the things that we've thought about for a long time, and we really see happening now, or starting to happen now, glimmers of it, green shoots, whatever you want to call it, is the impact that AI will have on science. And although the economic impact from that previous slide would be huge, for the long-term quality of life and improvement and change in society, AI that can autonomously discover new science or help people discover new science faster will be, I think, one of the most important things. And something that we're really trying to wrap our heads around. So I'm going to hand this over to Jakob to talk about research, and as I mentioned, we're going to share a lot about our internal goals and our picture of where things are.
Thanks, Sam. At the core,
Top news alert. Trump Xi to discuss tariff cuts tied to China's fentanyl crackdown, WSJ reports.
Called deep learning. And so a particular focus of ours is understanding what happens as you scale up training deep learning systems. And one consequence we discussed.
So if you guys don't know, this guy's been carrying OpenAI for years.
Artificial general intelligence. But we find that
allegedly,
in some way, even this maybe understates a bit the magnitude of the possible progress and change here. And so in particular, we believe that it is possible that deep learning systems are less than a decade away from superintelligence. So systems that are smarter than all of us on a large number of critical axes. And this is, of course, a serious thing, right? There's a lot of implications of this to grapple with. And one particular focusing impact of this technology and the technologies leading up to it, and something that we organize our entire research program around, is the potential to accelerate scientific discovery, to accelerate the development of new technology. We believe that this will be perhaps the most significant long-term impact of AI development, and it will fundamentally change the pace of progress on developing new technologies. And so thinking about how far along we are towards these goals, one good way to think about progress is to look at the time horizon that it would take people to accomplish the tasks that the models can perform. And so this is something that has been extending rapidly over the past few years. So where the current generation of models is at right now is about 5 hours. So if you can see this by looking at the models matching the best people in competitions such as the International Olympiad in mathematics or informatics. And we believe that this horizon will continue to extend rapidly. And this is in part as a result of algorithmic innovation, and a part
this guy's like the smartest guy in the world. Take notes.
And in particular, scaling along this new axis in context compute, also called test time compute, where we really see orders and orders of magnitude to go. So this is roughly how much time the model spends thinking, right? And if you look at how much time the models currently spend thinking about problems, and if you think about how much compute, how much time you would like to spend on problems that really matter, such as scientific breakthroughs, you should be okay using entire data centers. And so there is really quite a way to go there. And anticipating this progress, we, of course, make plans around it internally. And we want to provide some transparency around our thinking there. And so we want to take this maybe somewhat unusual step of sharing our internal goals and goal timelines towards these very powerful systems. And these particular dates, we absolutely may be quite wrong about them. But this is how we currently think. This is currently how we plan and organize. And so as a research organization that is working on automating research, naturally we are thinking about how does this impact our own work, and how will AI systems that accelerate development of future AI systems look like? How can they empower research like alignment? And so we are making plans around getting to quite capable AI research interns that can meaningfully accelerate our researchers by expanding a significant amount of compute by September of next year. So we believe that is actually quite close. And then we look towards getting a system capable of autonomously delivering on larger research projects and a meaningful, fully automated AI researcher by March of 2028. And so, of course, as we look towards these very capable systems, we think a lot about safety and alignment, right? And in fact, a lot of our work both on deployments and safety, but also just on understanding deep learning and developing this capability side, we can think of as preparation for these very capable models. Safety is a multifaceted problem. And so the way we generally structure our thinking are these 5 layers, ranging from factors that are most internal to the model to ones that are most external. And so at the core, right, and what we believe is the most important long-term safety question for superintelligence is value alignment. So to put this, value alignment you can think of as what is really the thing that the AI fundamentally cares about? Can it adhere to some high-level principles? What will it do if it's given unclear and conflicting objectives? Does it love humanity? And the reason we believe that kind of this high-level objectives or principles driving the AI are so important is that as we get to these systems that are thinking for very long, as they become very smart, as they tackle problems that are at the edge or perhaps beyond human ability, really getting to like complete specification becomes quite difficult. And so we have to rely on this deeper alignment. Then there's goal alignment. Does the agent interact with people? How does it interact with people? How does it do it following instructions? Then reliability. Can the AI correctly calibrate its predictions? Can it be reliable on easy tasks, express uncertainty on hard ones? Can it deal with environments that are a little bit unfamiliar? Then we have adversarial robustness, which is very related to reliability, but it's about adversarial settings. So can the AI withstand targeted attacks from human or AI adversaries? And then the outer layer is systemic safety, which are guarantees about the behavior of the overall system that do not rely on the AI's intelligence or alignment. So for example, this can be security, or what data does the AI have access to, or what devices it can use. And so we invest in multiple research directions across these domains. And we have seen quite a lot of progress also come from just the general development and improving understanding of deep learning as a whole. And I want to take a slightly deeper technical dive here and talk about a particular direction. Value alignment is a hard problem, right? It's definitely not solved yet. However, there is a new promising tool that aids our study of it. And that is chain of thought faithfulness. It's something we invest in very heavily. Starting from our first reasoning models, we have been pursuing this new direction in interpretability. And the idea is to keep parts of the model's internal reasoning free from supervision. So don't look at it during training. And thus let it remain representative of the model's internal process. So we refrain from kind of guiding the model to think good thoughts, and so let it remain a bit more faithful to what it actually thinks, right? And this is not guaranteed to work, of course, right? Like we cannot make mathematical proofs about deep learning, and so this is something we study. But there are two reasons to be optimistic. One reason is that we have seen very promising empirical results. This is a technology we employed a lot internally. We use this to understand how our models train, how their propensities evolve over training. Also, we have had successful external collaborations on investigating the model's propensity to scheme, for example. And secondly, it is scalable. And in the sense that explicitly we make the scalable objective not adversarial to our ability to monitor the model. And of course, an objective not being adversarial to the ability to monitor a model is only half the battle. And ideally, you want it to get it to help with monitoring the model. And so this is something we're researching quite heavily. But one important thing to underscore about chain of thought faithfulness is it's somewhat fragile. It really requires drawing this clean boundary and having this clear abstraction and having restraint in what ways you can access the chain of thought. And this is something that is present at OpenAI from algorithm design to the way we design our products, right? So if you look at the chain of thought summaries in ChatGPT, if we didn't have the chain of thought summarizer, if we just make the chain of thought fully visible at all times, right? That would make it kind of part of the overall experience. And over time, it would be very difficult to not subject it to any supervision. And so long term, we believe that by preserving some amount of this controlled privacy for the models, we can retain the ability to understand their inner process. And we believe this can be a very impactful technique as we move towards these very capable, long-running systems. And I'll hand back to Sam.
OK, that's very hard to follow with the rest of this. And obviously, that's the most important part of what we have to say. But just to reiterate, we may be totally wrong. We have set goals and missed them miserably before. But with the picture we see, we think it is plausible that by September of next year, we have sort of an intern-level AI research assistant, and that by March of 2028, which I believe is almost 5 years to the month after the launch of GPT-4, we have like a legitimate AI researcher. And this is the core thrust of our research program. There are two other areas we want to talk about, product and then infrastructure. On the product side, as we make this incredible progress with deep learning, we want to make it useful to people to sort of invent the future, as we mentioned. And what that's looked like traditionally for us is an AI super assistant inside of ChatGPT. But we're now really going to evolve to a platform that other people will build on top of, and all of the pieces that need to fit in of the world will be built by others. Before we go talk about that, I wanted to just show a quick video of how people are using GPT-5, some of the ways people are using GPT-5 in ChatGPT today.
I'm a quantum physicist. I'm a nail technician. Human immunologist. I'm a steelworker. A designer and developer. A professor of economics. I basically go fishing for a living. GPT-5 is able to predict the outcomes of experiments that we haven't even done.
Can you create a part numbering system that's easy for my guys in the shop? I want to catch Dungeness crab in the Bay Area.
I would ask a question about the application of a certain quantum operator. This one gives me a very detailed mathematics.
I ask for basically a camera app where I can draw real time in the air.
We have a theme. We have a direction to go. Let's go from 1 million or infinite amount of ideas to like, give me 10 or 20.
You just start testing it. You tell it jokes. You ask it questions like, what should economists do?
Different baits I can use, different water depths, all this information that it would take years to figure out on your own, a lot of trial and error.
It's tremendous for brainstorming. It's back and forth. I can kind of easily follow the reasoning. I don't need to trust the result. I can just look, what did it do?
GPT-5 just did this in one shot.
1,001 part numbers. It would have taken weeks for me to number this, and it would have made me go cross-eyed.
Jakob will join me back for Q&A in a little bit, but we're going to have one special guest on before the end.
Kick Jakob off.
We love that. We want much more of that. We want that everywhere. So we want OpenAI to be a platform that people and companies can build on top of. We can sort of see our way now to an AI cloud where this is not just in ChatGPT, this is not just services that we create, but we want to expose our technology for as many people to build the things that people will depend on and use and create with as possible. I think this quote, or at least this idea, is originally from Bill Gates. At least that's where I first heard it. That you've built a platform when there's more value created by people building on the platform than by the platform builder. And that's our goal. And that's our goal next year. We really think we can now take this technology and this user base and this sort of framework we've built and get the whole world to build amazing new companies and services and applications on top of it. To do that, there will be many things that we have to evolve towards, but there's two foundational principles as we move towards being this platform that I wanted to touch on. One is about user freedom. if this is going to be a platform that all sorts of people are building on, using, creating with, people around the world have very different needs and desires, and there will of course be some very broad bounds, but we want users to have a lot of control and customization of how they use it. Now, I made, one of my many stupid mistakes when I tried to talk about this recently. I wish I had used an example other than erotica. I thought there was an understandable difference between erotica and porn bots. But in any case, we were trying to show, the point we were trying to get across is that people need a lot of flexibility and people want to use these things in different ways, and we want to treat our adult users like adults. In our own first-party services, we may have, tighter guidelines, but AI is going to become such an important part of people's lives, the freedom of human expression is going to need to be there. Along with that, we think that the world will need to think about privacy in a different way than they have for previous kinds of technology. Privacy is important for all sorts of technology, of course, but privacy for AI will be especially important. People are using this technology in a different way than they've used the technologies of the past. They're talking to it like they would to their doctor, their lawyer, their spouse. They're sharing the most intimate details of their lives. And of course, we need strong technical protections on that privacy, but we also think we need strong policy protections of that privacy. We've talked about concepts like AI privilege, but really strong protections if AI is going to be this fundamental platform in people's lives seems super important to us. Okay, and then I want to go on to infrastructure. So I know there's been a lot of confusion about sort of where we are in our infrastructure build-out, and we figured we would just be super transparent about that. So where we are today, all of our commitments total a little bit over 30 gigawatts of infrastructure build-out, and that's about a $1.4 trillion total financial obligation for us over the next many years. This is what we've committed to so far. We, of course, hope to do much more. But given the picture we see today, given what we think we can see for revenue growth, our ability to raise capital, this is what we're currently comfortable with. This requires a ton of partnerships. We've talked about many of our great chip partners. There are people building the data centers for us, land, energy. There will be chip fab facilities. This is already getting to require quite a lot of supply chain innovation. And we're thrilled to get to work with AMD, Broadcom, Google, Microsoft, NVIDIA, Oracle, SoftBank, many others to really make this happen. But this is still early. If the work that Jakob talks about comes to fruition, which we think it will, and if the economic value of these things happen and people want to use all these services, we're going to need much more than this. So I want to be clear. We're not committing to this yet, but we are having conversations about it. Our aspiration is that we can build an infrastructure factory where we can create 1 gigawatt a week of compute, and we aspirationally would like to get that cost down significantly to like $20 billion a gigawatt over the 5-year life cycle of that equipment. To do this will require a ton of innovation, a ton of partnerships, obviously a lot of revenue growth. We'll have to repurpose our thoughts about robotics to help us build data centers instead of doing all the other things. But this is where we'd like to go. And over the coming months, we are going to do a lot of work to see if we can get here. It will be some time before we're in a financial position where we could actually pull the trigger and get going on this. 1 gigawatt is like a big number, but I figured we would show a little video to put this into perspective. This is a data center that we're building in Abilene, Texas. This is the first Stargate site. We're doing several of these now around the country, but this one is the furthest along. There's like many thousands of people that work here every day just doing the construction at the site. There's probably hundreds of thousands or millions of people that work in the supply chain to make all this happen, to design these chips, to fab these chips, to put them together. There's all of the work that goes into this for energy. There's an enormous amount of stuff that has to happen for each 1 gigawatt. And we want to figure out how we can make this way more efficient and way cheaper and way more scalable so that we can deliver on the infrastructure that the research roadmap requires and that all of the ways that people will want to use this need. To enable that, we have a new structure. So maybe you saw before this like crazy convoluted diagram of all of the OpenAI entities. Now it's much simpler. We have a nonprofit called the OpenAI Foundation that is in control of where the board sits, come back to the board, where the board also sits, and owns a slice of our PBC, Public Benefit Corporation, called OpenAI Group. So nonprofit in control, Public Benefit Corporation sits under it. We hope for the OpenAI Foundation to be the biggest nonprofit ever. As I mentioned now a few times, science is one of the ways that we think the world most improves, along with the institutions that broadly distribute the benefits of that. So the science will not be the only thing that the nonprofit funds, but it will be an important first major area of the things that we do. The nonprofit will govern the PBC. It will initially own about 26% of the PBC equity, but that can increase over time with warrants if we perform really well. And it will use these resources to pursue what we think are the best benefits of AI, given where the technology is and what society needs. The PBC will operate more like a normal company. It will have the same mission. It will be bound to that mission, and in matters of safety, it will only be bound to that mission. But it will be able to attract the resources that we need for that gigantic infrastructure build-out to serve the research and product goals that we have. So the initial focus of the foundation, we'll do more things over time, but we want to knock something out of the park, hopefully first, is a $25 billion commitment to use AI to help cure disease. There are a lot of ways this can happen, generating data, using a lot of compute grants to scientists, and also for AI resilience. AI resilience is a new and I think very important area, and I'd like to invite our co-founder Wojciech up to talk about what this will look like.
Wojciech! Hello. Glad to be here.
Thanks for being here.
So, term AI resilience is a little bit broader than what we historically thought about AI safety. So, in case of the resilience, we think that advanced AI comes with risks and disruptions, and we would like to have an ecosystem of organizations that can help to solve a number of these problems. So let me give you an example to better illustrate it. We all believe that the AI will advance in biology, and as it advances in biology, there is a risk that some bad actor could use AI to create man-made
Leave this guy alone.
pandemics.
He's a billionaire.
So on the safety level, the mitigation would be to make sure that the models block the queries that have to do with virology. However, if you consider the entire AI industry, it's very likely that even if OpenAI blocks it, someone could use different models out there and still produce pathogens. And in case of resilience, we don't want just to block it, but also have a rapid response if the problem would occur. So when I think about the risks and disruptions, there are just many. The mental health is one of them. Bio is another one. Job displacement might be another one. And we think that we need the ecosystem. And maybe a good analogy that I like is cybersecurity. So at the beginning of internet, it was a place that people didn't feel comfortable putting their credit card numbers because it was so easy to get hacked. And when there was a virus, people were giving each other a call to disconnect the computer from internet. And we got a long way. At the moment, there's an entire infrastructure of cybersecurity companies. They are protecting the critical infrastructure, governments, corporations, and individual users to such extent that people are willing to put the most personal data online to have life savings be online. So the cybersecurity got really far, and we think that something analogous will be present for AI, that there will be AI resilience layer, and I'm really excited that the nonprofit will help out to stimulate it to create such an ecosystem.
So am I. I think this is an important time to be doing this, and I'm very excited that you're going to figure out how we go off and make it happen. So again, these are not the only things that the nonprofit will fund, but we're excited about these as the first two, using AI to develop cures and treatments for diseases, and this new AI resilience effort as we figure out what the deployment of AGI into society is going to look like. So we mentioned that those are our three pillars, but what if this all works? We think it is plausible that in 2026 we start to see the models of that year begin to make small discoveries. By 2028, medium or maybe even larger discoveries. And who knows what 2030 and 2032 are going to look like. If AI can keep advancing science, as has happened in the past, we think the future can be very bright. Of course, we think it's very important that humans can self-determine our way through this future, but the open space that new scientific advances give us is quite impressive. So we asked Sora to help us imagine a radically better future by looking at the past. And we are particularly interested in how the history of science builds on itself, discovery after discovery. This is what we hope will happen with AI. You know, this is going to be 200 years of science. But if you can do these 200 years of compounding discoveries of the scaffolding building up on each other, not in 200 years, but in 20 years, or in 2 years, and if you look at how much this is accelerated and think about what could be possible before, you can imagine a world where a radically better future becomes quite possible. You have a data center here that is discovering a cure for cancer, a data center there that's making the best entertainment ever, a data center here that's helping you find your future husband or wife. This one is building rockets and helping you colonize space. This one is helping to solve the climate crisis. So we did all this stuff the old-fashioned way. And now, with the help of AI, we'll be able to shape what comes next with maybe much more power. So we talked a little about AI medicine. We're very excited about robots. We really think energy is very, very important to the world. We want to figure out what personalized education can mean, design novel materials, and probably a ton of other things that we can't even think of yet. So as we head into this next phase of OpenAI, and more importantly than that, this continual progress in deep learning, we thank you for joining us today. And we're going to try something new now, which is we're going to just answer questions. If this works, it's something we'll try more in the future. Jakob is going to rejoin for this Q&A. Thank you very much, Wojciech. But this is a new format for us, so bear with us as we try it this first time. Again, if this is useful, it's something we'll do, again, a lot more. And we're going to try to just answer questions in the order they are most upvoted. Are we good to go? All right, let's see how this works. So you can put questions in the Vimeo link, and we will just start answering them. So from Caleb, we've warned that the tech is becoming addictive and eroding trust. Yet Sora mimics TikTok, and ChatGPT may add ads. Why repeat the same patterns you criticized, and how will you rebuild trust through actions and not just words? We're definitely worried about this. I worry about it not just for things like Sora and TikTok and ads and ChatGPT, which are maybe known problems that we can design carefully, but we have certainly seen people develop relationships with chatbots that we didn't expect, and there can clearly be addictive behavior there. Given the dynamics and competition in the world, I suspect some companies will offer very addictive new kinds of products, and I think you'll have to just judge us on our actions. We'll have to, we'll make some mistakes. We'll try to roll back models that are problematic. If we ship Sora and it becomes super addictive and not about creation, we'll, cancel the product, and you'll have to just judge us on that. My hope and belief is that we will not make the same mistakes that companies before us have made. I don't think they meant to make them either. It's, we're all kind of discovering this together. We probably will make new ones, though, and we'll just have to evolve quickly and have a tight feedback loop. We can imagine all sorts of ways this technology does incredible good in the world, also obvious bad ones. And, we're guided by a mission where we'll just continuously evolve the product.
One thing that we are quite hopeful about in terms of what we optimize for in products like ChatGPT or Sora is thinking about optimizing for the very long term, which is naturally very aligned with how we think in general about extending the horizon on which the models can work productively. And so we believe that quite a lot of development is possible there, and we can eventually get to models that really optimize for long-term satisfaction and well-being instead of just short-term signals.
Okay, next question. Will we have an option to keep the Fora model permanently after adult mode is installed? We don't need to save for models, responsible adults. We have no plans to sunset Fora. We are not going to promise to keep it around to the heat death of the universe either, but we understand that it's a product that some of our users really love. We also hope other people understand why it was not a model that we thought was healthy for miners to be using. We hope that we build better models over time that people like more. The people you have a relationship with in your life, they evolve and get smarter and change a little bit over time, and we hope that the same thing will happen. But yeah, no plans to sunset Fora currently. Wow, we have a lot of 4.0 questions. All right, we're not going to, in the interest of time, we will not go through all of these. But yeah, we don't, we want people to have models that they want to use. We don't want people to feel like we're routing them around models. And we want adults to make choices as adults, as long as we think we're not, selling heroin or whatever, which also you shouldn't do. So
top news alert: analysis, activist investors deduce bank M&A after Holdco's Comerica campaign.
Okay, here's a good anonymous question for Jakob. When will AGI happen?
So I think in some number of years we'll look back at these years and we'll say, this was kind of the transition period when AGI happened. I think, one way we thought about, I think as some said, like early on at OpenAI, we thought about AGI kind of emotionally as this like thing that is like the kind of ultimate solution of all the problems, and it's this like single point for which there is before and after. And I think we found that it's a bit more continuous than that. And so in particular for like various kind of benchmarks that seemed seemed like kind of the obvious like milestones towards AGI. I think we now think of them as kind of like indicating like roughly how far away we are in years. And so if you look at the succession of milestones such as computers beating humans at chess, and then at Go, and then computers being able to speak in natural language, and computers being able to solve math problems, right? I think, well, they clearly kind of get closer together.
Yeah, I would say I think it's the AGI term has become hugely overloaded, and as Jakob said, it'll be this process over a number of years that we're in the middle of. But one of the reasons we wanted to present what we did today is I think it's much more useful to say our intention, our goal is by March of 2028 to have a true automated AI researcher, and define what that means than it is to sort of try to satisfy everyone with a definition of AGI.
And maybe one other thing to mention, right? Like I think like one kind of counterintuitive thing here is that obviously we're working with like pretty complicated technology. We're trying to understand all these algorithms, and maybe initially we kind of imagined that like AGI is the moment where you kind of have figured out all the answers, and it's kind of the final thing. And I think now we increasingly realize that there is kind of some curve of intelligence, maybe a multidimensional one, and humans are somewhere on it. And as you scale deep learning, as you develop these new algorithms, like eventually, well, you kind of inch closer to that point, and eventually will surpass it, and already have surpassed on multiple axes. And that doesn't actually mean you have solved all the problems around it, which is something we need to seriously think about.
Can you give us an idea of how far ahead internal models are compared to deployed ones?
I think we have quite strong expectations for our next models. So I think we expect quite rapid progress over the next couple months and a year. Yeah, I think, but we haven't been like withholding something extremely crazy.
Yeah. Yeah. Well, one of the ways this kind of often works in practice is there's like a lot of pieces that we develop, and that they're all kind of hard-won victories, and then we know that when we put them together, we will have something quite impressive, and we're able to predict that fairly well. Part of our goal today is to say that we have a lot of those pieces. It's not like we're kind of currently sitting on this giant, thing that we're not showing to the world, but that we expect by a year from now, certainly with this September of 2026 goal, that we have we have a realistic shot at a tremendously important step forward in capability. What is OpenAI, Ronan asks, what is OpenAI's stance on partnering with labs like Anthropic, Gemini, or xAI for joint research, compute sharing, and safety efforts? We think this is going to be increasingly important on the safety front. Labs will need to share safety techniques, safety standards, you can imagine a time when the whole world would say, okay, before we hit a recursive self-improvement phase, we really need to all carefully study this together. We welcome that collaboration. I think it'll be quite important.
One thing to mention on chain of thought faithfulness that I talked about earlier, we actually have started talking about establishing industry norms, and we started some joint investigations with researchers from Google and Anthropic, and some other labs, and yeah, that's something I'm very excited about, and I think that is an example of something where we can really benefit from collaborating across multiple labs.
Anonymous asks, will you ever open source some of your old models, like the original GPT-4? We might do those as museum artifacts someday, but they're not, like, GPT-4 is not a particularly useful open source model. It's big, it's not that good. You know, we could probably make something that is beyond the power of GPT-4 at a very tiny scale that actually would be useful to people. So for useful things, I expect more things like that. For fun museum artifacts, yeah, someday, who knows? Like, I think there could be a lot of cool things like that. Another anonymous, or maybe the same one, asks, will you admit that your new model is inferior to the previous one and that you're ruining your company with your arrogance and greed while ignoring users' needs? I believe that it is inferior to you for your use case, and we would like to build models that are better for your use case. On the whole, we think for most users, it's a better and more capable model. But we definitely have learned things about the 4.0 to 5 upgrade, and we will try to do much better in the future, both about better continuity and about making sure that our model gets better for most users, not just sort of people that are using AI for science or coding or for whatever. Yum asks, will there ever be a version of ChatGPT meant for personal connection and reflection, not only business or education? Yeah, for sure. We think this is a wonderful use of AI.
That was Elon. That was Elon.
This is meant to people's lives. We get
that was Elon.
Get a ton of emails and outreach from users about how ChatGPT has helped people in difficult personal situations or to live a better life. And like, this is what we're here for. I mean, this is like as important as anything that we do. Like, we love to hear about scientific progress. We love to hear about people that, you know, got diagnosed with a disease and got cured. But the personal stories are incredibly important to us, and we're thrilled about that. And we absolutely want to offer such a service. Your safety. Okay, two parts of this. Two questions that are about tied from G and Anonymous. Your safety routing breaks user trust in workflows by overriding our choices. Will you commit to revoking this paternalistic policy for all consenting adult users and stop treating us like children? When do users get control over routing? Where's the transparency on safety and censorship? Why can't adults pick their own models? Yeah, I don't think the way we handled the model routing was our best thing ever. There are some real problems with 4.0, and we have seen a problem where people that are in fragile psychiatric situations using a model like 4.0 can get into a worse one. Most adult users can use those fine, but we do, as we've mentioned, we have an obligation to protect minor users, and we also have an obligation to protect adult users who are not in a frame of mind where, you know, we're reasonably likely that they're choosing what they really want and we're not causing them harm. As we build age verification and as we are able to differentiate users that are having like a true mental health crisis from users who are not, we of course want to give people more user freedom. As we mentioned, that's one of our platform principles. So yes, expect improvement there, and I don't think this was our best work in how we communicated the previous rollout. How we strike the right balance between protecting people and allowing adults to speak about difficult things without feeling policed. You want to say anything there?
Yeah, so definitely there is a problem where we aim to lay out the kind of high level policies and guidelines for the model in the spec that we developed for ChatGPT, but the space of situations you can find yourself in is enormous, and at some point, kind of like establishing the right boundaries really becomes a tough intelligence problem. And so we are seeing improved results on these metrics from reasoning models and from expanding more reasoning on thinking about this softer questions and trade-offs. Of course, this is like a bit more difficult to train for also than math problems, for example, and so this is something that we're researching quite heavily.
Kate says, when in December will adult mode come? Will it have more than just NSFW? When writing even slight conflict, when writing triggers filters on 4.0? I don't know exactly when in December it will ship, but yes, the goal is when you are using OpenAI to help ChatGPT to help you with creative writing, it should be much more permissive in many categories than the previous models are. Again, we want this, and we know users want this too. If this is going to be your personal tool, it should help you with what you're doing, and every time you hit a content filter for something that is, feels like it shouldn't, we understand how annoying that is. So we're going to try to fix that with adult mode. There may be new problems that we face, but we want to give people more flexibility. Anonymous says, why does your idea of safety require lying to users about what model they're actually using? Again, I think we misrolled this one out, but the goal here was to let people continue to use 4.0, but in the situations where 4.0 has behavior that we think is actually really harmful, before we have all of the age gating in that we'd like, to kick it, to put the user into a model where they are not going to have some of the mental health problems that we faced with 4.0. 4.0 was an interesting challenge. It's a model that some users really love, and it was a model that was causing some users harm that they really didn't want. And I don't think this is the last time we'll face challenges like this with a model, but we are trying to figure out the right way to balance that. Will we get into legacy models back for adults without rerouting? Rerouting, yes. Will the December update officially clarify OpenAI's position on human-AI emotional bonds, or will restrictions continue implicitly defining such connections as harmful worldwide? I don't know what it means to have an official position. Like, we build this tool, you can use it the way you want. If you want to have like a small R relationship and you're getting something like empathy or friendship that matters to you in your life out of a model, like, it's very important to us that the model faithfully communicate what it is and what it isn't. But if you as the user are finding value in that support, again, we think that's awesome. Like, we are very touched by the stories of people who find value, utility, a better life in the emotional support or other kinds of support they get from these models. Kylo says, how is OpenAI increasingly allowing so many features for the free version users? I can answer this from a product and business perspective, but Jakob, I think it might be useful for you to just talk about the incredible rate at which models are getting more capable for lower prices and less amounts of compute.
Yeah, we are seeing quite a lot of ability to, as we get to like the new frontiers of intelligence, to reduce the cost for that quite quickly. And so, yeah, especially with reasoning models, we've seen that actually quite cheap models, when allowed some additional test time compute, can become much more capable. Yeah, and so this is something that I expect will continue. And so, yeah, as we talk kind of about getting to these new frontiers and automating research and so forth, I expect that the cost of a lot of that will keep falling quite a lot too.
So, yeah, we talk a lot about the increase in model capability, and for pushing forward science, that's hugely important. One of the most amazing things that I've observed about AI is, over the last few years, the sort of price of a particular unit of intelligence has fallen about 40x per year for the last few years. So when we first had like GPT-3, we thought it was very cool, and it was at this cost that was kind of hard. And like GPT-3 scale models now basically run for free, like on a phone or something. The cost of a model that's as smart as GPT-4 at the time we launched it relative to now has fallen hugely. And we expect this trend to keep going. Now, we still think we need a ton of infrastructure, because what we continue to find is the cheaper we can make it, the more people want to use it, and I expect that only to increase. But our goal is to drive the cost of intelligence down and down and down, and have people use it for more and more things. That will allow us to continue to offer lots of features for free. But that will also mean, I think, that people who really want to spend a lot on pushing AI to the limit to cure a disease or figure out how to build a better rocket or whatever will spend a huge amount. We are committed to continuing to put the best technology we can, as long as we can make the business model even sort of work, into the free tier. And you should expect a lot more from us there over time. Okay, Anonymous asks, will an age verification start that allows users to opt out of the safety router, a waiver that could be signed releasing OpenAI from any liability? We're not going to we're not going to do the equivalent of selling heroin or whatever, even if you sign a liability. But yes, on the principle of treat adult users like adults, if you're age verified, you will get quite a lot of flexibility. We think that's important, and clearly it resonates with the people asking these questions. Anonymous also asks, is ChatGPT the Ask Jeeves of AI? We sure hope not. We don't think it will be. Okay, since we only have 10 minutes left, we're going to, and some of these touch other things that we've already touched on. We're going to skip down through some of the same questions and try to get to more. In future sessions, we can do more of these if we don't get to everything here. Just as the Macintosh, Noah asks, just how the Macintosh was the precursor to the iPhone, do you see ChatGPT as the OpenAI product, or do you see it as a precursor to something much greater that truly reshapes the world?
So I would say, like, as a research lab, we haven't set out to build a chatbot originally, although I think we've since come to appreciate how aligned this product is with our overall mission. And we, of course, expect ChatGPT to continue to become better and be this way for people to interact with increasingly advanced AI. But we do anticipate that eventually AI systems will be capable of creating valuable artifacts, of actually pushing scientific progress forward, as we were discussing. And I believe that will be the real lasting legacy of AI.
I think the chat interface is a great interface. It won't be the only interface, but the way that people use these systems will change hugely over time. If you think about what Jakob shared earlier of the 5-second, 5-minute, 5-hour tasks, if you think about a 5-year or 5-century task that would take something that would take humans, it's hard to even think about what that means. But probably you want a different kind of product experience. I also think you probably will want this to feel more like a sort of ambient, always present companion. Like right now, you can ask ChatGPT something, it can do something for you. But it'd be really nice to have a service that was sort of just observing your life and proactively helping you when you needed it, and helping you come up with better ideas. And just, I think we can probably push very hard in that direction. Neil asks, I love GPT 4.5. It's by far the best on the market for writing, and it's the main reason I pay for Pro. Could we get some clarity on its future, please? We think we're going to have models that are much better than 4.5 very soon, and for writing, much, much better. We plan to keep it around until we have a model that is a huge step forward in writing, but we don't think 4.5 is that good anymore. We'd like to offer something much, much better.
But yeah, we are definitely not done with that direction of research. And yeah, we expect combining that with other things we're working on, we'll get wheelfiles that are dramatically better than 4.5 on all axes.
Do you have any sense of timing to share about when you think we have a model that is dramatically better than 4.5 on this kind of task like writing, and also anything about like how far that's going to go?
Next year, I think, is definitely what I expect.
When is ChatGPT Atlas for Windows coming, asks Lars. I don't know an exact time frame, some number of months, I would guess. It's definitely something we want to do. And more generally, this idea that we can build experiences like browsers and new devices that let you take AI with you, that get towards this sort of ambient, always helpful assistant, rather than something you just query and responds. This will be a very important direction for us to push more on. Will you disclose the documents with the opinions of the 170 experts so that we'll have some transparency regarding the new justifications for model behavior? I will ask Fiji Simo how she'd like to handle that, but I think we could, I don't know exactly what we'll be able to share, but I think we should do something there, and I think more transparency there is a good thing. Anonymous says, I've been a pro user since month 2. As a researcher and fiction writer, I feel GPT helps me think clearer. I lost the question. Sorry, that was a really good question. Let me try to find it again. Clearer but not freer. Has imagination become an optimization casualty? What do you think?
It is. I think it is definitely possible for our current systems that, you know, I think if you compare a model like 4.5 to a model like O3, I would expect that like there will be trade-offs there. I think there are definitely like transitory as we like figure out our way around these technologies, and so again, like I expect this will get better.
Yeah, I think there are going to be population scale. Like one of the sort of strange things I've noticed is people in real life talking in like ChatGPT ease, where they sort of use some of the quirks of things ChatGPT says. And I think there will be other things like this where there's like this coevolution of people and the technology in ways we can't totally predict. But my expectation is over time, people are much more capable, much more creative, think much more expansively and much more broadly than they do today. And we certainly see examples of this where people are just like, I never would have been able to keep this in my head. I never would have been able to have this idea. And then we hear other examples where people say, you know, I've outsourced my thinking and I just do what this thing tells me. And obviously, we're much more excited about the former than the latter. Can you help us understand why you build emotionally intelligent models and then criticize people for using it for accessibility reasons when it comes to processing emotions and mental health? Again, we think that's a good thing. We want that. We're happy about that. The same model that can do that can also be used to encourage delusions in mentally fragile users. And what we want is people who are using these models intentionally, the model's not deceiving the user about what it is and what it isn't, the model's being helpful, the model's helping the user accomplish their goals. We want more of that and less of anything that would feel like the model tricking a user, for lack of a more scientific word. We totally get the frustration here, like to, you know, whenever you're trying to stop something that is causing harm, you stop some perfectly good use as well. But please understand the place we're coming from here is trying to provide a service to adults that are aware of it and that are getting real value from it, and not cause unintended harm to people who don't want that along the way. All right, given that we have just a couple of minutes left, let's see if there's any questions in very other directions that we should try to get to. Okay, when do you think massive jobs loss will happen due to AI? From Razi.
So I think already we are at a point where I think a lot of the gap that stops present models from like being able to perform a lot of intellectual jobs is more about integrations and interfaces than maybe raw intellectual capability. And so I think we definitely have to think about that. Think about automation of a lot of jobs as something that will be happening over the next years. And I think this is a big thing for us to collectively think about, like what are the jobs that will replace those, and what are the kind of new pursuits that we'll all engage on.
This is a question from me, not from the live stream. What do you think meaning will look like? What do you think the jobs of the future will look like? How do you think when AI automates a lot of the current things, like how do you think we'll derive our fulfillment and spend our time?
I expect yeah. Well, I think this is a quite philosophical question. I think it can go in many directions, but some things I expect. I think the high level goal setting, right? Like picking what pursuits we're chasing. That is something that will remain human, and I think that is something that a lot of people will derive meaning from. I think also just the ability to understand so much more about the world, the wide, the incredible variety of new knowledge and new, also entertainment, but also just intelligence that will be in the world. I think will provide quite a lot of meaning and fulfillment for people.
Okay, rapid fire, 2 minutes. Shindy says, when GPT-6?
I think in some ways maybe that's more of a question for you. In that, like, I think with GPT-5 we have with previous models, right? Like GPT-4, GPT-3, like we've kind of like kept very tight connection of like how we're training new models. So like what are the products that we ship, and as I was just saying, I think right now there's a lot to do on the kind of integration side and on the so for example with GPT-5 is the kind of the first time we really bring reasoning models as kind of our flagship, our main flagship model, and so we're not coupling like these releases and these products as tightly to our research program anymore.
Yeah. I don't know either exactly when we'll call it that, but I think a clear message from us is, say, 6 months from now, probably sooner, we expect to have huge steps forward in model capability. Felix asks, is an IPO still planned, and how would the structure then look like? Are there rules in place for increasing capital? We don't have like specific plans or this is exactly when it's going to happen, but I think it's fair to say it is the most likely path for us given the capital needs that we'll have and sort of the size of the company. But that's not like a top of mind thing for us right now. Alec asks, you mentioned being comfortable with the $1.4 trillion of investment. What level of revenues would you need to support this over time? What will be the largest revenue driver? It can't just be a per user subscription. Eventually we need to get to hundreds of billions a year in revenue, and we're on a pretty steep curve towards that. I expect enterprise to be a huge revenue driver for us, but I think consumer really will be too. And it won't just be the subscription, but we'll have new products, devices, tons of other things there as well. And this says nothing about like what it would really mean to have AI discovery and science and all of the revenue possibilities that would unlock. And as we see more of that, we will increase spend on infrastructure. Okay, we are out of time. Thank you all very much for joining us and the questions, and we will try to learn from this format and iterate on it and keep doing these sorts of Q&A. Thank you very much.
Yeah, I don't think there was too much there. There's a couple of interesting things, but looking forward to Q3 earnings. So global GDP is 117 trillion. Can one company get $1 trillion of it? I don't see why not. Actually quite reasonable. Railroads were still a big chunk of GDP for a while. So, I mean, NVIDIA's revenue as part of global GDP is actually not that high. It would not be crazy for it to reach 1%, right? Why would, you know, That's reasonable. But even then, the stock's kind of fairly valued. So that's kind of what it already has to do. So if it reaches... So if it maybe doubles that, you could get a 10 trillion, 15 trillion market cap. Well, yeah, I guess no specific one utility reached that much market cap, and utilities were regulated to not have too much profit. But this is an interesting question. I don't think too many people have asked. It'll be fun to do some research on this. Okay, I gotta go to the bathroom, maybe take a break. I'll definitely be back for the close. Don't go anywhere. INQ dropping rapidly here. Still, I'm waiting for a colleague to get out of a meeting, so I have a little more time here. Polymarket has Zoran here at 90%. Still pretty
that drug pharmacy dude, Martin, what's his name?
Martin Shkreli.
Shkreli.
And what the fuck? What the fuck, though? Why still work when you're rich? Spoken like a true loser. Unbelievable. I don't want to achieve anything other than sustenance. Once I can sustain myself, I will never work again. What the fuck kind of a lazy piece of shit are you? Fucking loser mentality. Loser, get out my stream. Disgusting. Leave Hood Shkreli alone. We don't, you know, he was never supposed to be there. Never supposed to be there. Nah. Retired, man. Yeah, D-Wave isn't eligible for NVQ Link. NVQ Link is just NVLink. Jensen selling you a Mellanox. Fuck that bitch. Women will cheat on you. Fuck that bitch. Get money. Get money. You have to worry about her. Get some money. You're still in college, man. Women aren't important yet. Relationships are just make-believe. It's just a game. You don't need that. Fuck that bitch. For real, though, what's her Instagram? For literally no reason. Yeah, nobody in hedge funds like Zoran. Jensen's like, oh, you guys raised money? Give me that. Fucking give me that. If you're 26, I hate to tell you this, but that girl was for the streets. She for the streets. No, I'm not planning to go to Bali. Probably get kidnapped and murdered. She for the streets. That ain't your girl. That's our girl. We all got to know her very well. No comment, Raul, man. You don't bait me. Don't bait me. No hedge fund for me. Am I allowed to own a hedge fund or operate a hedge fund? I guess it's the same thing, isn't it? Maybe not. I don't travel too much, no. 3-6 Mafia, yeah, man. That's Juicy J. Now there's girls who are value players. You got momentum players. You got value players. You got all kinds. You got distressed debt. They're like a dude in a rut. There's not too many distressed debt players for real, but they're mostly, yeah, you're right. Girls are mostly momentum longs. You got some girls that are straight haters. They're short only. That's a lesbian. She's short only, man. You got girls who have international, you know, they're emerging markets. Get women who specialize in Asia, North America. Yeah. Got that FOMO. A little cyclical. That's a fact. They cyclical. Let's go, Ion Q. Let's go, D-Wave. Keep dropping, baby. I just don't like to travel. You got the quants. You know they got quants. Hell yeah, they got quants. Bitches quants. She's calculating everything. You got baggies. That's true. women are not assets, okay? Women are human beings. You weirdos. To cherish. Sell you a course. Yeah, okay. First thing you gotta do. Let me see here. What's a good course? Okay. Start with this. Read this book cover to cover. Okay? That's your first course. Read the fucking book. Got it? Okay. When you're done with that, come back. Give you the next one. Get Baby Rudin. Yeah, I want you to read. I want you to read this one. Differentials. Okay? All right? I want you to try this. Okay? Page 2, chapter 8. How to stop being a baggie. Okay? Okay? Come back when you're done. Classic. This you just read on the toilet, okay? This is easy. It's too easy. It'll be good. It'll be good. Read a lot. That's my course. It's free. Read a lot. Read a lot of fucking books, okay? When you're tired, you don't want to read more books, read more fucking books. Again. Okay, don't read blogs, don't read the internet, read books, real books. Okay, learn how to be patient and get rid of that ADHD. Stare at the wall for an hour if you have to, just to practice. Okay? Linear algebra is the key to all of math. You can't really go far in math without some linear algebra. Essential to everything. Anything you want to do in math, linear algebra is involved. Get used to it. You don't know linear algebra? You're shit. You're shit, you're garbage. I'm going to put you in a dumpster. Never heard of Immunovac. Have not done too much private bio investing, but how does it relate to investing? How does it relate to investing? My man, it's 2025. You can invest with a computer. You better understand some math. Train your brain a little bit at least if you don't use it. Quantum Crash? You're watching it. I miss the old Shkreli. The set on his goals Shkreli. The always up Shkreli. Man, I used to really admire Shkreli. He had the trashy cat Shkreli. On probation Shkreli. Now there's so many Shkrelis. I thought I was Shkreli. Sorting bio Shkreli. Buying Wu-Tang Shkreli. I purchased ebooks? Sure. SMB Shkreli. Okay, I'll turn up the audio. Sorry about that. Now he glazed Shkreli. He's all reformed Shkreli. Has a son Shkreli. Okay, bio Shkreli. Thank you, thank you. What is the AUM of QBTZ? 50 million. That's it? We could probably break it, right? Shout out to Kanye West. I like Sarepta. Sarepta is my stock. Abivax as well. Spruce, the Spruce Moose. One day we'll wake up and Spruce is 300 or something. And I won't be dreaming. Cure breaks 70. Wow. And the INBX, man, I sold that on Friday. Somebody in Godel chat scared me. Asshole. I should ban him. My son is so good. He's so cute. We'll add Euronext. We got to meet. I met a lot of people, man. Come on. Don't do that. Don't do me like that, man. You could if they're man, come on, man. Don't do that. I plead the fifth, Shkreli. Got arrested. I sold the Cure too, man. Okay, I have this thing to do. I have to do it. Come on, let's go. That's a dream. Oh, I might go and Patrick bet David. You guys know who that is? PBD. Stop it, come on, you know I can't help it. We're on. Was it? Da 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 da. Wow, look at NVIDIA Go 201, and you have quantum cracking. It's very unusual. I'd love to apply for a pardon. That would be great. I really need that, actually. So if you guys know anybody, just let me know. It's pretty important. That would be great. I don't know Eric Trump, man. Sorry. Why don't you guys all email the office of the pardon attorney for me? That'd be almost like be really nice. They'd be like, "Oh man, a lot of people like this guy." Be like, "Yeah, you know, something like that." You have you done? Drop the link. I don't know the link is. I don't know what the link is, man. Stocks do look overvalued. I mean, my portfolio is short quantum stocks. There's like 6 of them, sort of. Kind of. Yeah, I would short the crowded trades. If you're the last person in the trade, you're the sucker, not the genius. Some of y'all stupid as hell. I wasn't happy when he mentioned quantum, but I had faith. Not stupid. Man, Eric Jackson, come on. What a fucking... One book I like, I'm not sure how much it's going to help you, but it's called Code by Petzold. When will the bottom fall out? Is this yet another fake bottom? Or fake, I don't know, what do you want to call it? Breakdown? Tokenization of real estate is not cool. I don't understand what good that'll do you. Your real estate's already tokenized. It's called a deed. We've had a lot of down quantum days without it crashing forever. So keep that in mind.
Top news alert. U.S. stocks Wall Street indexes climb amid earnings optimism and Nvidia gains.
Open is down. Open door. Yeah, I don't know. There is hope. Maybe Zoran will drop further. Who knows? Our house in the middle of the street. That song was a banger. Let's get the Hasids out. Yeah. Swing this whole election, baby. My Orthodox homies, too. Let's have the Jewish people of New York show them what we're made of. Bernie Sanders here, listen, even though I'm Jewish, I support Zoran. Why? Because I'm not really Jewish. I support Palestine. Palestine, the Middle East, everyone but Israel. Yes, it's true, I'm Jewish. I don't like it when people mention it. Our house in the middle. Allah Akbar. Bernie Sanders here. Allah Akbar. Me and Larry David, we're practicing our prayers. We're globalizing the Intifada, or whatever it's called. And you should donate more to my campaign, young one. Yes, I've decided to become Muslim. AIPAC? What's AIPAC? AIPAC? What is it? Never heard of it. Anyway. Yeah, so I've traded Forex. No, I didn't see that. Have I ever been depressed? Yeah, right now. Of course. Our house in the middle of the street. Mm-hmm. Of course, we've looked at Evolution Gaming. What are you, crazy? I have not traded Syndax ever. Quantum coin? That sounds terrible. Sounds worse than Bitcoin. What is this Bitcoin? Fuck hack the Bitcoin. No, I'm just saying depression's a part of human existence. We all have depression. Sometimes. Sometimes I get the feeling. No, I don't. I think some of the most depressed people are very wealthy. You know, it's not about that. You can be poor and happy and rich and sad. I mean, there's no rule. Yeah, the summit's a big question about data integrity. Is the Chinese data representative of the United States data? Or is it one big fugazi? Nobody knows. NVIDIA 203, congrats. Congrats to all those who celebrate. Oh, 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 oh. Oh, 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 oh. Dun, dun, dun. I mean, to really get my mind around Summit will take some time. It's have to study each study very carefully, what's been released, what hasn't. It's not an easy job. Gotta go all around the world to China and other places to really investigate. Branch Davidian. I mean, Branch Nvidian. Listen, if Trump wants to meet up, you go to wherever Trump is, okay? That's it. Bottom line. 'Cause Stone Cold said so. That's the bottom line. 'Cause Stone Cold said so. Yeah, I see William in the cut. I see William in the back. Talking shit. Yeah, there's sometimes that data you can do it over and over again until you get it right. You gotta keep trying until you replicate it. Is that how it works? These are the best chips, potato chips. I love the chips. They're really advanced chips, from what I hear. The best chips. Tremendous chips. They're tremendous. Tremendous chips. Intelia, patient died. Or is dying. I hope he doesn't die. No, I don't think Barron's insider trading. I know him pretty well. That is not his MO. I have tissues ready because I have nasal polyposis and I'm constantly sneezing and have allergic rhinitis. Is that okay with you? Is that all right? Do I have to ask your permission to have a tissue box nearby? Billions and billions of chips. The best American chips. All right, somebody ban this guy, Monkey. I'm done with him. Fucking weirdos on the internet, man. He'll grow up. Grow up. Both of you guys. Look at all these guys. The hell is wrong with you people? He died like a dog. This isn't your chat, man. This is you're in a sophisticated investment club here. All right, act like it. Act like you're at Mar-a-Lago. All right, that's again very weird, Dusted. Like, I really don't like that kind of language. Weirdos, man. We live in a society.
That drug pharmacy dude, Martin, what's his name?
Martin Shkreli.
Shkreli.
Wow, look at this sell-off. Look at this beautiful sell-off into the close. I love it.
10 Canadian dollars is like $3, yeah. $3 US.
China. 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 China.
China. China. No, we didn't have soundboards when I worked. There's no soundboards at hedge funds. You're funny, though. You're funny. You're funny. China. I just keep shorting more capper. They're capping. We know they're capping. It's cap. All right, folks. Absolutely cap. D-Wave. I didn't work on his show. I worked at his fund. I have a good relationship with Xi. Believe me, he's at the top of his game. He always liked to say that. Yeah, looks like the White House isn't giving out any checks to anybody. Huh. Only AMD. Huh. How about that? I see. Banana. Yeah, I think the available funds for trading changes based on the margin. I think it's called. I believe it's called margin. That's what they call it. Margin. They use the margin. They get the call. It's a margin call. We take their money. Guys, some of you are really like invading my personal space, and I don't appreciate it. Okay. Just please stop. Okay, this is my personal time and personal space. Portfolio is all short. All short. Yeah, tell me about it, Clark. All short quantum? You may be familiar with quantum. It's an advanced technology that we're gonna beat China. 2. We don't like
Surprise, motherfucker.
China. 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 China.
Yeah, I think we should do that P. Waker. I agree with you. I don't think Jensen said anything. You don't have to link those two things. Expensive stocks just have a tendency to drop. There's not always a cause and effect that you can tease out. Yeah, he stressed the one logical qubit, which made it sound like we're far away. But this was also kind of one of the last catalysts, and it seems like Jensen was just trying to shill GPUs to quantum, not really actually excited about the technology. He's just like, oh, these guys can use quantum. I'm sorry, these guys can use GPUs. Great. But if he actually liked quantum, he would be investing in it and doing stuff like that, and he's obviously not really doing that. So can I interest you guys in Q-Link? And you know, there's still no investors in quantum. There's no like people really excited. New York City, some people say, is the greatest city in the world. I mean, maybe you don't like it, but some people do like it. Some people like it. No, I didn't watch Martinez with Friedberg. How was it? Oh my gosh. Completion of supervised release. Let's go. You have completed supervised release. You are hereby discharged from the supervision of this office. Probation officer. Let's go. Oh, that scumbag Capers was the chief U.S. probation officer? Unbelievable. Does Schwab have a 200% margin requirement for capper? How do I get around? Should I buy puts?
Okay, mid-November. Are they going to screw us with the November? Secret position is on hold. I guess I can try to buy puts for Capricorn instead of the short. Trorilliazol. Capper, the Capricorn. They got the Capper. Let's see. So we've got October. No, just November puts, right? Nov is the next expiry. Nov 1. I'll say Nov 21. We got the 1s, the 2.5s, the 4s, the 5s, 6, 7.5, 9, and 10. As well, go to the 11, 12.5, 15, 17.5. Okay. I wish that there was a Discord for Capricorn, or like some kind of cringe. Did they report Q3? It doesn't sound right. Some cringe Reddit or something. Okay, that was Q2. So they'll report Q3 around the time of the result. But I'll take away 25 total. Would it trade below cash by any chance? I don't know. Let me do like a few different analyses. So I could do below cash per share, current cash per share. It's a little bit different. That's this cash minus the closed quarter, right? Q3 is closed. And we're 1 month closed of Q4. Okay. And then if it trades below cash, it could, I've seen companies trade a whole year below cash, but let's do 6 months below cash. You get $1.80. So the 2.5 puts don't look too exciting.
Top news alert. NVIDIA will build AI supercomputers for U.S. Energy Department, announces total bookings of $500 billion.
Oh, I didn't know they announced $500 billion in bookings. I must have muted that part of the call. Oops. Okay, so if the 2.5s are trading for 20 cents, the 4s are trading for 67.5 cents. Let's see what the fair value. Yeah. I mean, you can buy the 4 and 5 and 6 puts are not bad, but I mean, this is a rough one. Praying this thing kind of goes up, right? Man, there's too many arbs out there. Too many smart funds are out there. Hard to make money. It's all right. It's better to not do it than force it, right? Like, you don't want to force it. Forcing it's for losers. We're not going to force it. We're not going to force it. No puts are risky if they don't announce by December. If they announce after November 21st, yeah. Well, let's see. If they go to the current cash, the numbers get a little better. Some of those more than double. And if they go to like $2, you get a pretty good return on some of these, like the 4s. So maybe the 4s. What's wrong with the audio? Oh shit. Yo. Check. Mike was literally popping. It's like short circuiting. That was so weird. Did you hear that? Did anybody hear that? That was so weird. Okay, let's get ready to rumble. Oh! The fuck? Why is the mic busting? That was weird. I know, it's good mic and everything.
Sector update, tech stocks mixed late afternoon. Raphael Holdings mourns the passing of lead independent director Steven Greenberg and announces the appointment of Alan Grayson to its board of directors.
Nurkren. Wow. Chronicity selling really well. Whew, unbelievable, actually.
The latest, Category 5 Hurricane Melissa makes landfall in Jamaica with record strength. Daybook Tuesday agency. Daybook Tuesday Congress Trump. Daybook Tuesday Congress at. Mid-Southern Banker Inc. announces updated range of per share consideration and dissolution payment and payment record date.
Bomboclat.
International lawyer Robert Amsterdam issues urgent warning to U.S. investors, businesses, and government over Spain's tax abuses. Photos show Hurricane Melissa's impact on the Caribbean. Earnings flash, EXL Service Holdings Inc. posts Q3 adjusted EPS $0.48 per share versus FactSet est of $0.47. Earnings flash, NBIX Neurocrine Biosciences Inc. posts Q3 adjusted EPS $2.17 per share versus FactSet est of $2.07.
Bomboklat. Rasklat.
Earnings flash, CSGP CoStar Group Inc. posts Q3 adjusted EPS $0.23 per share versus FactSet est of $0.18.
Bomboklat.
Earnings flash, EXE Expand Energy Corporation reports Q3 revenue $2.97 billion versus FactSet est of $2.710 billion.
Yeah, I don't think NVIDIA needs a government stake. Bati boy. Booking. Okay, bookings reporting.
Brief InvenTrust Properties Q3 EPS
Booking beat.
0.8.
Yeah, booking beat. PayPal beat, right? Quarter's going well. Me bomba clad. Pussy clad. Wagwan.
Earnings flash, IVT InvenTrust Properties Corp. reports Q3
Oh,
revenue
IQM put up
$74,500,000 versus FactSet est of $73,400,000.
IQM press release. IQM collaborates with NVIDIA on NVQ Link. IQM Quantum, global leader.
Guidance CSGP CoStar Group expects Q4 adjusted EPS range $0.26. Deals of the day, mergers and acquisitions.
What actually is NVQ Link? Nobody mentioned.
Cumberland Pharmaceuticals to announce Q3 2025 financial results and company update. Earnings flash, CSGP CoStar Group Inc. reports Q3 revenue $833,600,000 versus FactSet est of $813,200,000. Tigo Energy reports third quarter 2025 financial results. OrthoPediatrics Corp. reports third quarter 2025 financial results.
Yeah, it's a private company, but very interesting that they put out a press release on it.
Mondelez International reports Q3 2025 results. Baytex Energy Corporation expected to post a loss of 4 cents a share. Earnings preview.
We're getting out with the same press release.
Fittest Energy declares $0.56 25 quarterly cash dividend. U.S. stocks, Wall Street indexes post records as NVIDIA jumps mega cap earnings ahead.
Tim Costa.
Neurocrine Q3 earnings snapshot. Nat gas producer Expand Energy post profit in third quarter. Brexit partly to blame for high inflation, says Rachel Reeves. U.S. equity markets end higher amid expectations of another Fed rate cut.
The D-Wave has nothing to put out. Let's see what the fuck this NVQ Link is.
Earnings flash, PPG Industries Inc. posts Q3 adjusted EPS $2.13 per share versus FactSet est of $2.08.
Yeah, let me see the specs. What's the spec?
Asian business headlines at 8:03 p.m. GMT.
Wait, this is...
Earnings flash BE Bloom Energy Corporation post Q3 adjusted EPS $0.15 per share versus FactSet est of $0.09.
NVQ
Earnings flash Loggage International SA reports Q2 revenue $1,190 million versus FactSet est of $1,180 million.
It's just a 8X B200. Doesn't make any sense. Yeah, how do I get started? Let me get
Earnings flash EIX Edison International post Q3 core earnings flash EIPS $2.34 per share versus FactSet est of $2.16. Earnings flash STXC8 Technology Holdings PLC reports Q1 revenue $2,630 million versus FactSet est of $2,550 million.
They don't even have any
guidance. STFCH Technology Holdings Plus expects Q2 adjusted EPS
no
range
details
$2.55, $2.95.
There's no page here.
Earnings flash CWSC Zern LK Water Solutions Corporation post Q3 adjusted EPS $0.43 per share versus FactSet est of $0.40. Earnings flash ENPNH Enphase Energy Inc. reports Q3 revenue $410,400,000 versus FactSet est of $369,300,000. Slow release of hostage bodies threatens Gaza's ceasefire and deepens families' heartbreak. Live markets, Wall Street wows with its own triple play. Guidance EVRNS Varonis Systems Inc. specs Q4 adjusted EPS range $0.02. Logitech second quarter earnings boosted by AI-enabled products. Spelman College professor secures $483,620 NIH grant to transform genomic data science education. Earnings flash FLS Flowserve Corporation posts Q3 adjusted EPS $0.90 per share versus FactSet est of $0.80. Casino operator Red Rock's Q3 revenue beats estimates, partly helped by Las Vegas operations. Binance UCT Ultra Clean Holdings Inc. expects Q4 adjusted EPS range $0.11, $0.31. Earnings flash Visa posts fiscal Q4 adjusted EPS $2.98 versus FactSet est of $2.97. Mondelez International forecasts bigger decline in annual profit. Visa quarterly profit rises on strong transaction volumes. Reveal delivers solid results in first 9 months of 2025. Earnings flash LSTR Landstar System Inc. post Q3 adjusted EPS $1.22 per share versus FactSet est of $1.24. Earnings flash LSTR Landstar System Inc. reports Q3 revenue $1,210 million versus FactSet est of $1,200 million.
Even Elon loved our last model.
Earnings
I'm
flash
excited to show you
CWH
our
Camping
latest
World Holdings
Sonic
Inc. reports
3.
Q3 revenue
Now, can you tell which
$1,810
one's the
million
real Elon?
versus FactSet est of
I don't really have a
$1,740
business
million.
What's the business plan?
The answer is neither.
Earnings flash
Both are
MBIN
Sonic
Merchants
3.
Bancorp reports
Here's
Q3
the
revenue
thing. Even my
$171,100,000
voice was
versus
AI
FactSet est of
generated
$163,900,000.
Sonic 3 is the best model for real-time conversation. Let's see it in action.
Hi, this is Sarah calling back from Saffron Kitchen.
Another robocall.
I get that a lot. So, were you looking to make a reservation?
Yeah, tonight for 2 at 8.
8 o'clock? Got it.
Oh wait, actually, honey, does meet here much tonight?
Oh, अच्छा, काम खत्म होने में time लगेगा. 8:30 then?
Actually, wait. Do you take walk-ins?
Uh-huh. But it gets pretty packed. Better to have the res.
Got it. Yeah, 8:30 works.
Sounds great. So to confirm, your phone number is 641-212-6201.
Yeah, thank you.
Thousands of businesses like ServiceNow, Cresta, and Decagon are powering millions of conversations with Sonic every month. You heard it in action. Sonic 3 has breakthrough naturalness, fine-grained control over volume, pacing, and laughter, and support for 42 languages. It's the fastest and most reliable voice model on the market, 3 to 5 times faster than OpenAI and more accurate than 11 Labs. Try it right now for free at Cartesia.ai or book a demo. We're so confident we can help you build the most realistic voice AI that if we can't, we'll donate $5,000 to a charity of your choice. As part of our launch, we're giving away a guide to build the best AI voice clone of you in under 10 minutes. You can get it to make reservations, handle customer support, or even call your friends. Retweet, bookmark, and comment Sonic below, and we'll send you the guide and $100 in credits so you can start building right away.
Come on, Curtis, drop out. Satya. Oh, no.
Question like Jock, where you stay? Tell a college ball, where the chop call.
No.
20 grand, spend a grand at the bar. Just about his own. J's on my feet. I'm on that Patron, so get like me. We gotta give y'all a hit. Damn near every day.
No fucking way.
Where you stay? Tell a college ball, where the chop call. Hit 20 grand, spend a grand at the bar.
Yo, no way. So I guess he's sort of implying implying 500 million in revenue, right? We were just talking about this earlier. I'm at 290. I need to get to 400. That's a lot bigger.
Top news alert. U.S. stocks, Wall Street indexes post records as NVIDIA jumps mega cap earnings of
Yeah, I can't believe D-Wave was able to get annealing in the same conversation. It's kind of impressive. Yeah, can you guys not hear me well? But yeah, I think the D-Wave thing was is impressive, William. Yeah, great. Oh, thank you, thank you. I love you guys. Try Godel, GodelTerminal.com. Joby, gonna use NVIDIA too? Quote unquote partner. Yeah, send us money. I don't know how Sarepta will do. We'll see. Public Zoom link? Oh boy. That's gonna be fun. Is that tomorrow? Is that tomorrow? We gotta invade that. Oh, wait. Never mind. I would never do that. I would never do that. I would never do that. I think what 5150 means on the top of my screen are the longs, and that's correct. The bottom of my screen are kind of the shorts. I think that's what you mean, and that is correct. I don't think he's talking about charts. Well, TradingView doesn't really do news. It doesn't have a community. It's got some other good things, but it doesn't really approach Wall Street in a sophisticated way. And things like sell-side research or Wall Street people, expert networks, none of those things really make sense to TradingView. But, you know, it's a good program. I mean, it's not bad. But I don't think they have a roadmap that really is very exciting. I don't think they have a roadmap at all. It's mostly been the same product for a while. You can connect Fidelity and Robinhood, correct. I think TradingView has good charts. You know, they're very good at that. They have good, thorough asset class coverage, you know, but not being a terminal makes it very tough to use. You got to click around a lot. Nobody likes to click around a lot. Yeah, AI isn't too useful for finance, unfortunately. At least the way people think it might be useful. Did Humor report? What a joke. Three-hole ATEVs. I don't know what options flow. What does that mean? Yeah, I saw Anthropic did. I don't think too much will come from this stuff. Quantum had a pretty significant rally for a few days, but it's coming back down, it looks like. My P&L is just 100% tied to Quantum at this point. Yeah, it's so funny. Humacyte had an oversubscribed deal for warrants. You have an oversubscribed deal for warrant coverage. What the fuck? Don't say it's oversubscribed. It's so oversubscribed, you wouldn't have to do the warrants. So dumb. $5 trillion. Yeah, Capper's pretty small. But I am starting to build it up. I added to it today. Cult figure for sure. Yeah, that's me. Yeah, I kind of feel like quantum's about to collapse, so I don't know if I want to, how crazy I want to get into Capper. I have to decide that basically. But I like those 4 puts, they're not bad. And I have other positions like Spruce. I don't know, most people think that OI drug doesn't work, but it could have a surprise. Yeah, it's almost all, at the end of the day, given how much quantum moves. It's almost all in quantum. I even have puts as well. Yeah, I think people are going to get pretty disappointed when the government never invests in quantum. I don't know, I just have a feeling. I do think Joby is a scam too, but there's a lot of scams right now. I don't know much about Intel. It seems like parallel computing has been the main thing. Yeah, I'm willing to take some risks. Some house money now, Brad. And, you know, I'd been punished on this trade for a long time, so I'm excited to see it kind of go the other way for once. Hopefully it continues into tomorrow, but there's no guarantee of that. I don't know anything about Caesars. You're on your own on that one. Farm has always been a dead sector, man. Me and Vivek made it hot. Oh, we'll be on Capper Watch. I'm still going to trade Capper. I just don't know how much. I definitely want to do Capper. AVXL. Scamavax. If I could go back, I'd go long quantum. Are you crazy? I have dreams of going back in time to trade. I would love that. Yeah, Capper doesn't have too much meat on the bones, you're right. Well, I'm not the best programmer in the world, so no, I did not develop this complex full stack app. Oh, oh, sometimes I get the feeling. No, I don't think delusion can last years and years. That doesn't make sense. Maybe. Maybe. Never say never. Not sure saw the news or not, but the market's been going up. If the economy falls off a cliff, maybe. Yeah, still working on cracking Bitcoin when I have free time, which more and more I don't. Should short selling be illegal? Yes. Yes. I'm not snoring. That's just how I breathe, okay? Don't make fun of me. That baby boy. The fuck is this?
Top news alert. Judge intensifies oversight of agents in Trump's Chicago immigration acquisition practice and taxes and disimportment practice.
da, da, da. Da, 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 da. Man, I want to play some video games. I ain't trying to work, bruh. Oh, my baby boy needs an email address. I need to email him. Need to email him from the future. Man, I got a crowded ass office. Look, you can't even see, but there's lots of dudes back there working. They're mostly behind this wall over here, but my office. What I do. Oh man, I fucked this up. Okay, there we go. That was expensive ass. No. Yeah, you like that, Willie? You like that shit? Right? Thing? Had a nice run. Fatty fat man. Hell yeah, you gotta go to office and work your ass off. That's called business. It's good ass business. Trying to do no bullshit. Yeah, I don't know what the. Dealing with these XLRs when I was in a rock band. Screaming like crazy on the track. I can't even hit a note right now, man. Can't even hit a note. Can't hit no goddamn notes. Talking about tra-la-la. Itsy bitsy spider. Can't even sing that, man. How am I supposed to make a hit? How am I supposed to make a #1 hit, man? Oh, MacDonald had a farm. E-I-E-I. Oh. Oh. Oh, MacDonald. That's all I got. Can't do no more. I could have been a contender. I could have been the best. I could have been #1. You broke it. Twinkle, twinkle, little star. I still got the baritone though. Still got the baritone. Oh. No, I never bought puts on Beyond. I short stock like a man. I don't trade options. Not as big as you would think, Brian. Bumbleclad. What rasclad dog is that?
Which bumbleclad dog I am? Cause this morning I wake up good enough. Give me a good blood clot dog. What kind of little bumbleclad dog this am I give? He can't even bark louder blood clot. He can't even defend me.
Check me out. Look. I have no talent. Oh, no, really, I mean it. I don't belong on this track.
I'm about to end this man's whole career.
Never had any talent. That's what they said. They were right. I suck at this. But I won't stop trying. Actually, I did. I quit. What are the other people in my office doing? Well, so this is a software company. Maybe we make software. Make the best of software. Yeah, we got DEI. Yeah, do crack cocaine. Why not? Little crack cocaine. That's what's up. That's what's up. Yeah, I'm not sure I would go after Nebius if I were you. Oh, sometimes I get the feeling. Ba 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 da ba dum ba. We use a combination of course, JavaScript on the front end, Python on the back end, a little bit of Rust, a little bit of C. What else? I think that's it. Oh, Java. A little bit of Java. I think it's a mix of business to business and business to consumer. I mean, I think high-end consumers. But, you know, when you build the whole infrastructure, you should be able to service everyone. I mean, interactive services, both. There's no reason why you can't do both. Oh, sometimes. No, I try not to gamble at the casino. That's not my jam. Yeah, we use Kubernetes, less so Docker. But we definitely fuck with Kubernetes. Yeah, it's your boy. Haha. Yeah, I play poker. Yeah, for sure. I like poker. Nitro, yeah. I mean, we use some Docker images, but I mean, we're container pros. We know what we're doing, but yeah. All right, I gotta take some meetings. I'll see you guys tomorrow. I love you guys. Try Godel, godelterminal.com, and I'll see you later. Bye-bye.